The clocks on Mars were never meant to disagree. Yet somewhere on that silent red world, they do. If you could read the raw mission logs of the rovers, just the timestamps, the heartbeat of every command, you would notice something strange. Not dramatic, not cinematic, something quieter. Something that feels like a whisper, running beneath the surface of a desert that should have been silent for billions of years. It began as a few stray microseconds, drifting away from the expected timeline. The kind of anomaly a tired engineer might dismiss after an 18-hour shift. The kind of mistake that disappears once the data is cleaned and smoothed and made ready for a public press release. But this drift did not disappear. It repeated. And then, more unsettlingly, it repeated only in certain places. Curiosity was the first to show it just a small misalignment, when it crossed a patch of terrain so ordinary it would never catch the eye. Perseverance echoed the same misalignment nearly a decade later, but only inside a thin crescent of Jezero's ancient rim. In every case, the clock slipped slightly, as if time itself had just shifted its weight from one foot to the other. Not enough to frighten anyone, just enough to be impossible. The Martian landscape itself offered no clues. Endless plains of basalt, windwork dunes that shift by millimeters a year, craters softened by epochs of slow erosion, sky the color of faded peach, nothing that should disturb time, and yet something did. The strangeness grew heavier the more the engineers looked. For decades, mission planners trusted the internal clocks of the rovers with absolute certainty. These clocks were the quiet backbone of every maneuver, the steady hum behind every command, the silent metronomes that ensured communication windows opened and closed with astronomical precision. For them to drift meant something deeper was wrong, something fundamental, something that should not have the ability to change. For a moment, imagine each rover as a small beating heart on an empty world, its clock pulsing, ticking, keeping time, while the desert lies unmoving around it. Now imagine that heart passing through a place where the beat changes not because the machine changes, but because the space around it breathes differently. That was how the first scientists described it in private, as if the planet itself were shifting its breath. They didn't publish it. They didn't announce it. They only circled the numbers, highlighted them, wrote quiet, marginal notes that no one outside the lab would ever see. A drifting second, a microsecond gained or lost, a heartbeat stepping slightly out of line, and always at the same coordinates. Like dust falling unevenly in a glass hour, like time thinning, just for a moment. Like a ripple in something we have always assumed was perfectly flat. That was where the wonder began. Not in anything visible, but in the idea that the invisible might be changing shape. You are listening to Whispers of the Universe. If your gentleness is awake tonight, let a small trace of it remain with us, soft enough to keep this quiet place breathing. Engineers at JPL had trained their whole careers to distrust surprises. A rover cannot afford to be surprised. A machine parked on an alien world has no luxury of improvisation. It survives by obedience to the expected. So, when the first drift appeared in Curiosity's logs, no one considered cosmic mysteries. No one whispered about strange physics. They checked the hardware first: the quartz oscillator, the thermal shielding, the error correction loops, the radiation counters. One by one, each suspect was tested, isolated, dismissed. The oscillator held stable. The shielding performed nominally. The error loops showed no corruption. The radiation levels were flat. Still, the clock drifted. Then, they considered temperature. Mars can swing through more than 100 degrees Fahrenheit in a single sol. Cold is a merciless editor of electronics. But the drift did not correlate with temperature. There were sols colder and sols warmer, where the clock stayed perfectly aligned. Then they checked vibration, perhaps a sudden jolt, a wheel slipping, a rock lodging itself under a tire. But the drift did not correlate with motion either. Sometimes it appeared while the rover was still, sometimes while it moved smoothly over dust as soft as powder. They checked code corruption. Nothing. Logged voltage fluctuations. Nothing. Solar flare interference. Nothing. Memory wear. Nothing. The drift refused to attach itself to any cause. It existed alone, clean, traceable only to the ground beneath the wheels. As if time itself were anchored to the soil. That hypothesis, though no one dared call it that aloud, was enough to send the investigation deeper. The Mars Reconnaissance Orbiter was consulted. Charade, its radar instrument, had mapped subsurface strata for years, slicing into the crust with radio waves and returning echoes that told a slow geological story. When they overlaid the drift coordinates with Charade's data, a faint pattern emerged. At 3 of the drift sites, radar returns were strangely muted, not absent, not misaligned, just softened, as though the ground absorbed more signal than expected, as though the subsurface were not behaving like rock or ice or dust. But Charade's resolution was limited. It could not say what lay below, only that something was swallowing the echo. Maven, orbiting high above, carried instruments tuned not to rock, but to air, to the tenuous ionosphere that stretches over Mars like a thin veil. And Maven had seen something too. Faint oscillations in atmospheric charge, small waves rising and falling in a rhythm that should not exist on a planet with such a thin, quiet sky. On most sols, nothing. But on a handful of sols, those same sols, when the rover clock slipped, the ionosphere trembled just slightly out of pattern. It was never enough to be considered an anomaly, never enough to alarm mission control, but enough to be measured, enough to be matched, enough to say that something, somewhere between soil and sky, whispered a rhythm that machinery could detect but humans could not feel. Different instruments, different domains, different missions separated by hundreds of miles, all tracing the outline of the same invisible shape. The scientists did not call it a discovery. They were careful. Scientists survive on carefulness. But privately, among the people who knew the data best, a quiet phrase began circulating. Thin places in time, not ruptures, not tears, nothing violent, nothing dangerous, just places where the density of the moment seemed altered, as though time itself had been stretched slightly, pulled gently, softened at the edges, a landscape where the seconds were fewer grains in the hourglass, a terrain where the pace of existence slowed or quickened by the faintest measurable breath. Time thinning, like the air, like the light, like the dust that drifts in long, slow arcs through Martian dawn. One physicist, in a notebook that would never be published, wrote, "If Einstein is right, and time bends to mass, then perhaps time also bends to absence, to hollowness, to voids we cannot detect, to shapes in space-time we do not yet have names for." It was a thought too large for the lab, too soft for a report, but impossible to erase. The idea that Mars might have places where time itself feels loose. Such an idea forces the mind into deeper corridors, into the possibility that time is not a flowing stream, but a field with texture, a sea with currents, a fabric with tension points, a breath that rises and falls with landscapes older than memory. What if time is not uniform? What if it has thickness? What if, like air pressure or gravitational gradient, it can change from place to place? If so, the rovers were the first creatures in history to feel those changes, not with nerves or skin, but with quartz and code. They recorded those changes without complaint, little mechanical monks crossing a world that has forgotten the meaning of time entirely. And still, the drift appears only in certain places, only in thin arcs of land, only where the planet seems to murmur something old and quiet through its stone. If time can thin, then somewhere else, it must also thicken. And if the rovers have brushed the edge of such a place, if their clocks have sensed the boundaries of something unseen, then the next step is unavoidable. To follow the drift, to trace it, to descend into its shape. The doorway does not close here. It leans open, waiting, as the dust continues to settle in slow, uneven spirals across a world that has only begun to reveal what it has been holding. The next traces lie deeper, waiting in the coordinates ahead. There are maps of Mars that everyone has seen. Topographic maps, mineral maps, ancient lakebed maps, wind erosion maps, maps marked by color gradients and contour lines, interpretations of a planet made from the long gaze of machines. But there is another map. A map almost no one has seen. A map that was never meant to exist at all. It does not track dust or stone or slope. It does not track craters. It does not track water ice or volcanic plains. It tracks something far more delicate: the places where time falls out of step. It began as a collection of isolated coordinates, nothing more than a quiet list of locations where a rover's internal clock had slipped by fractions too small to frighten any bureaucrat, but far too precise to ignore. When the data scientists at JPL plotted those coordinates across the Martian surface, they expected chaos, random scatter that could be dismissed as coincidence or noise. But the coordinates did not scatter. They clustered, not tightly, not in a pattern the eye could easily decode, but in shapes, pale, ghost-like shapes, as if drawn by a hand that did not wish to be noticed. 3 clusters appeared first, then 5, then 7 as new sols returned fresh logs. Not circles, not grids, more like smudges, like the faint shadow of a sound you're not sure you heard. A map of unsteady seconds. None of these regions were large. The biggest, barely half a kilometer across, the smallest, only a few dozen meters. Yet each one seemed to hold a subtle drift, a tiny easing of the second hand, a soft distortion of how the rovers kept rhythm. The scientists stared at those clusters for hours, searching for geological meaning. Were they remnants of ancient water flow? No. The shape didn't match deltas or channels. Were they volcanic deposits? No. Too small, too irregular, too scattered. Were they magnetic anomalies? No. Mars's magnetic field is fragmented, a patchwork quilt of dead volcanoes and fossilized magnetism. But these sites did not line up with any of those. One researcher whispered that the clusters looked like bruises. Small, subtle, inexplicable. Another said they resembled shallow lakes in time, as if the second itself pooled differently there. A poetic exaggeration, perhaps, but not entirely wrong. For the first time, they began to see time not as a universal constant, but as something that behaved like any other field, something that could expand, contract, ripple, distort, soften, something that could be mapped, even if the mapping was incomplete, even if the story hid beneath layers of silence. One by one, analysts began overlaying the drift clusters with everything they could find: thermal data, wind vector fields, soil composition, subsurface density estimates, ancient shoreline projections, magnetometer readings, even seismic echoes recorded by InSight before its mission ended. Every overlay told the same story: no clear pattern, no classical explanation, nothing to ease the discomfort. But buried in the noise, one pattern emerged, a soft one, too soft to declare, but too consistent to ignore. At the edges of each time drift region, the rover's accelerometers registered the faintest mechanical tremor, not a vibration from the wheels, not turbulence, and not seismic activity, just a shift, like stepping onto ground that behaves differently under pressure, as though the space itself beneath the rover felt slightly looser, slightly less anchored, slightly detached from the rigid fabric that governs ordinary moments. It was not enough to trip a safety alert, not enough to throw any dust, but enough to convince the analysts that the drift was not an instrument's imagination. The rovers truly felt something subtle, something real. At night, when only a skeleton crew monitored the mission feeds, the data scientists quietly created a new file, a living document, where every new drift coordinate would be logged. They called it, unofficially, the Time Density Map. The name was never used aloud. It was typed once, hesitated over, deleted, typed again, and then never touched. They did not know if time had density. They only knew that something about it varied. And the rovers seemed to skim across those variations, like ships crossing thin patches of ice. Time, in this sense, was not a river. It was a surface. And surfaces have texture. This idea began to grow quietly, taking root in the minds of those who studied the anomalies late at night, those who had stared at the data long enough to feel its pull. What if seconds have depth? What if they have weight? What if time, as it drapes itself across a planet, sags or tightens in places we haven't learned to perceive? What if Mars is old enough, quiet enough, and empty enough for those sags to become visible? One researcher scribbled a thought in the margin of her notebook. Perhaps time responds to the contours of emptiness, the way wind responds to the shape of dunes. It was a strange idea, That time might curve not only in the presence of mass, but also in the presence of absence. That void itself might have geometry. That something could be missing beneath those drift coordinates. Something carved away, or hollowed out, or dissolved long ago. A cavity not of rock, but of space-time. To explore this idea, the researchers compared the drift clusters to InSight's seismic readings. InSight had spent its mission listening to Mars the way a physician listens to a heartbeat. Quiet, patient, attentive. Most of Mars was steady, predictable, a slow drumbeat beneath ancient crust. But at the drift sites, the seismic echoes behaved strangely, not louder, not quieter, just slightly delayed, as though they had passed through a region of stone stretched thinner in some imperceptible way. Sound travels differently in stretched material. Waves slow, energy disperses, the echo elongates. So does time. The correspondence was faint, subtle enough that skeptics could dismiss it with ease. But those who had watched the drift for years did not dismiss it. They saw a hint of something deeper, as though Mars had pockets where the very fabric that holds seconds together was stretched taut or pulled thin. The scientists did not speak of this publicly, not because they feared ridicule, but because they did not yet possess the language to describe what they saw. Time, to them, had always been the quiet coordinate behind every coordinate, the invisible line on which all other lines depended. Now that line was bending, almost imperceptibly, like a horizon seen through heat, a distortion that suggests a truth just out of reach. The researchers began using a soft metaphor in their private conversations. They compared the drift sites to eddies, tiny currents swirling at the edges of a larger flow. What if time on Mars flows like a slow-moving sea? What if those drift clusters are its eddies, places where the current curls back on itself, slows, warps, sinks? At planetary scale, the effect would be negligible, invisible, meaningless to physics as we know it. But to a rover, a creature of quartz and precision, it would be noticeable, measurable, recorded without emotion. An unsteady second, a moment stretched or compressed by the smallest breath of a world too old to explain itself. As the months passed, the map of unsteady seconds grew richer. The drift clusters multiplied. Patterns formed. Not enough to declare a discovery, but enough to suggest a presence not of matter, but of behavior. Time behaving differently in certain places, for reasons no instrument could name. The scientists began planning the next phase, to send a rover deliberately into the heart of a drift region, to measure not only clock alignment, but every sensor simultaneously, listening for something, anything, that might reveal what lies beneath. But before they could begin those plans, another discovery surfaced. Something in the old Viking mission logs. Something overlooked for almost 50 years. A single line, written by an engineer long dead. Clock offset observed during Sol 179. No mechanical explanation. The earliest thin place in time had been seen before, half a century earlier, but never recognized for what it was. The idea landed in the JPL lab like a quiet tremor. This phenomenon was older than curiosity, older than perseverance, older than every rover now wandering the Martian deserts. The map of unsteady seconds stretched backward through decades, back through missions long ended, back toward a planet that had been whispering the same uneven rhythm long before anyone thought to listen. And if the drift had been there all along, hidden in forgotten logs, waiting through decades of silence, then the question became impossible to avoid. What exactly is shaping these thin places? The answer does not arrive here. It waits ahead, quiet as dust, pulling us toward the next ascent, where the first, deeper hypothesis begins to take form. There is a sound Mars makes that almost no one hears, not a sound in the air, for the air is too thin to carry anything more than a ghost of a whisper, but a sound beneath the crust, a vibration through stone, a trembling that travels the long, cold bones of the planet. InSight listened to that sound for 4 years. It pressed its seismometer into the soil, like a monk placing an ear to an ancient door, waiting for whatever story might seep through the wood. Most of the time, the sound was steady, predictable, the soft settling of dust, the The slow cooling of rock, the pressure squeeze of a world that has been dead longer than life on Earth has existed. But sometimes, rarely, Mars made a different sound, a lingering vibration, a tremor with no clear source, a pulse that did not fit the usual taxonomy of Marsquakes. And when the researchers layered those strange pulses over the time density map, a quiet alignment appeared. Not a perfect overlap, not a clean lock, but an uneasy echo. The mysterious seismic lingers sat near the edges of the thin places in time, as if the planet itself were responding to those distortions, as if stone knew when the second misbehaved. No instrument had been designed to feel time, yet the crust seemed to feel it anyway. One seismologist stared at the overlay for nearly an hour before saying, very softly, "This is not a coincidence. It feels like feedback." Feedback, a strange word for geology, but not the wrong one. On Earth, feedback between time and matter is microscopic, lost in the noise of oceans, storms, tectonics, lightning, machines. Nature's chaos drowns any whisper of space-time subtlety. But Mars is quiet. So quiet that even the smallest pulse is noticeable. So still that variations in the very flow of seconds might ripple into matter. If time loosened its grip, even by a tiny fraction, stones might settle differently. Stress lines might shift. Echoes might stretch a hair longer. And insight, a patient ear pressed to the planet, might hear that stretch. The team began to study the seismic linger more deeply. Each pulse lasted longer than expected, decaying more slowly, as though the planet resisted letting go of the vibration. A normal Marsquake dissipates like a dropped pebble in sand, quick, clean, absorbed. But the lingers were different. Their decay curve extended just enough to suggest the wave traveled through a medium slightly altered. Not softer, not harder, something else. As if space-time itself had changed the acoustic properties of the stone, enough to slow the dying echo. One physicist wrote, half amused and half unnerved, "Imagine tapping a bell that rings in a different universe. The sound wouldn't be wrong, it would just feel off." That is what the linger felt like. A sound from a place where the rules were bent ever so slightly. Still, skepticism persisted. Some insisted that the pulses were artifacts, misreadings, noise, thermal creaks, even dust devils. But the dust devils were predictable, and these pulses were not. They appeared when the thin places in time were active. They faded when the thin places fell silent. A planet breathing with a broken rhythm. The next question became unavoidable. Were these distortions caused by something physical beneath the crust? Or were they signatures of something more subtle? A deformation in the fabric of space-time itself? The researchers turned again to Charad, hoping the radar maps could provide clarity. But Charad's signal, when passing over the drift sites, refused to behave. It returned shallow echoes where deep ones were expected, and deep echoes where the ground should have been thin. It was as if the radar were trying to look into a place that was not fully there. One analyst described it as watching a reflection tremble on the surface of water that doesn't know it's supposed to be still. Below some drift regions, the radar found no clear boundary between ice and rock, no solid interface, only gradients that faded into ambiguity, as though layers beneath had lost their crispness. Not melted, not eroded, blurred. A blurring of matter, a blurring of time. The scientist compared the blur depths to clock drift magnitudes. A pattern emerged. The stronger the drift, the deeper the blur. As if the distortion in time extended downward into the crust itself. This was the first moment when the team began to wonder if the thin places had shape, if they were not merely surface anomalies, but vertical structures, columns of space-time stretched thin from ground to some unknown depth. What forms such structures? Gravity? Mass deficit? Thermal gradients? Magnetic fractures? None of the classical answers fit. A new term surfaced in private conversation: temporal shear. Not a term from textbooks, a metaphor at best. But metaphors often become theories, and theories often begin with questions no one wants to speak aloud. Temporal shear, the idea that space-time might slide or stretch slightly in response to stresses we do not yet understand, like fabric pulled taut in some regions, loose in others, wrinkled where forces gather. On Mars, where the crust is cold and brittle, where nothing interferes. Perhaps those wrinkles become linger echoes. Perhaps the rovers were crossing those wrinkles, and their clocks, being the most sensitive instruments to the flow of time, noticed before anything else did. As the team dug deeper into Viking's old logs, they found something even more unsettling: a second drift from Sol 463. This one larger, and ignored at the time because the priority was soil chemistry, not temporal precision. The Viking entry read, "Clock shift observed during traverse. No correlation to thermal or radiation." That was the same language the modern teams had used, almost word for word, separated by generations. It meant the phenomenon was not new. It had not emerged recently. It had been part of Mars all along. The thin places in time may have been whispering since the first human machine touched Martian soil. The idea brought a quiet weight to the room, a sense of standing at the threshold of a mystery that did not belong to any one era of science. If time is misbehaving on Mars, it is not doing so for our benefit. It is doing so because that is the nature of Mars. The scientists looked at the seismic linger again, the stretched echoes, the blurred subsurface, the drifting seconds. Taken alone, each anomaly could be dismissed. Together, they formed a pattern too delicate to ignore: a multi-layered tremor, a quiet distortion, a signal that exists across domains: mechanical, acoustic, electromagnetic, temporal, as if something beneath the crust were not merely a structure, but a presence not of matter, but of behavior. Time behaving differently in those regions, and matter responding. If space-time can ripple, and if those ripples pass through stone, what happens when they reach deeper strata? What happens when they touch reservoirs of frozen water, or ancient volcanic tubes, or caverns carved by processes no longer active? Do they resonate? Do they amplify? Do they accumulate over eons? No one knew, but the data hinted at one thing. The distortions were not surface-bound. They were subterranean, rooted, reaching down through the crust like invisible roots. One geophysicist compared the pattern to the branching of fault lines, only inverted. Instead of cracks in rock, they were cracks in time. But cracks suggest rupture, and nothing about this phenomenon felt violent. It felt old, patient, slow. A property of the planet, not a disruption. The seismic linger, the radar blur, the clock drift, each a different sense organ responding to the same unseen contour. If humans could perceive time with the same sensitivity as machines, perhaps they too would feel the slight tilt, the subtle pull, the uneven breath of the planet. The team began planning a new kind of experiment, one that would track not just the timing anomalies, but the shape of the distortions themselves. The first step was obvious: remap the thin places with higher precision, not with rover paths, with deliberate traverses. A rover would need to enter the heart of a drift site, remain still, and wait. Let time reveal its shape. But before any mission proposal could be written, new data arrived. A single drift event far stronger than any before, recorded by Perseverance, unexpected, deep, almost 10 times larger than the median drift. And it occurred not at the center of a thin place, but at the edge. Edges are important. Edges show gradients. Edges reveal change. This drift was not subtle. It was unmistakable. A second hand dragged forward like a breath pulled too deeply. The team stared at the spike on the chart in silence. Something had happened. Something that changed the entire map. The thin places were not static. They were moving. That realization did not end the chapter. It opened it wide, pulling the researchers toward the next question, a question waiting in the movement itself, where the boundary shifts lead deeper still. And that question draws us onward, toward the next descent, into what begins to take shape beneath the drifting seconds. The first sign that the thin places were moving came quietly. No alarms, no dramatic spike, just a subtle deviation on a graph. A drift not at the center of a known region, but on its outskirts. Edges matter. Edges are where gradients reveal themselves, where transitions speak, where boundaries stop pretending to be stable. The team watched Perseverance's anomalous timestamp shift with a silence that felt alive. A drift 10 times deeper than the median would normally trigger a dozen investigations. Thermal checks, radiation comparisons, clock recalibrations. But this drift aligned with none of them. It simply existed, a solitary peak on a calm plateau, quiet as a heartbeat skipping in a sleeping body. When they plotted the location of the new drift, the map bent, not a glitch, not a scatter, a bend. The cluster's boundary shifting outward by roughly 27 meters. Then, several sols later, another drift occurred, this time 41 meters from the original border. By the end of the month, the team had recorded 5 such shifts, each one marking the edge like a new ring on a growing tree. The thin place was expanding, not uniformly, not predictably, but undeniably, like a slow tide rising over unseen contours. To understand such movement, the scientists had to abandon every intuitive model they had. Time, in classical physics, does not drift laterally across terrain. It does not creep like fog. It does not migrate like dunes. It does not grow. Yet something on Mars was behaving as if time could. One researcher offered a thought late one night, his voice weary, as though the idea had been fighting for air inside him for days. What if we're not seeing movement in time, but movement in the structure that shapes time? A quiet shift in space-time tension, a redistribution of stress, a reconfiguration of something older than geology. He wasn't proposing magic. He was proposing mechanics. But mechanics in a domain humans had barely begun to imagine. Perhaps the thin place was not expanding. Perhaps the underlying distortion was adjusting its equilibrium, settling into a new configuration after millennia of stillness. Like ice cracking, like metal cooling, like planetary crust flexing under a pressure no instrument had recognized yet. A slow rebalancing of a hidden system. To test this idea, the team analyzed the shallow seismic lingers collected near the border during the shift. They found that the frequency ratios had changed, not drastically, but enough to imply that stress in the subsurface had redistributed. Something underground had shifted, not a quake, not a collapse, more like a long, deep exhale through stone, as if the distortion in spacetime had nudged matter aside. The researchers returned to the radar blur in Sherad's maps. Previously static, the blur now seemed to have changed shape, elongated slightly, tilted by a few degrees. Subtle, too subtle to prove definitively, but not subtle enough to dismiss. The distortion wasn't just drifting horizontally. It was twisting, rolling like a slow, invisible wave. A geophysicist compared the map overlay to a topographic shift. A physicist compared it to the curvature of space-time around mass. Another scientist suggested something even stranger. What if this is not a distortion in space-time, but a boundary between two temporal pressures? Temporal pressure, a phrase with no formal meaning, yet instantly evocative. On Earth, pressure differences create fronts. Weather boundaries, thermal boundaries, acoustic boundaries. Why should time, if it has density, not behave similarly? A pressure front in time would not behave like a wave. It would creep. It would expand unevenly. It would reshape itself according to whatever lies beneath. Like fog curling around unseen ridges. If the thin place were a low-pressure region in time, its borders might move the way atmospheric fronts do, sensitive to gradients, pushed by invisible forces, guided by contours hidden deep within the planet. Mars's ancient fractures, its lava tubes, its buried sediments, its pockets of ice, all could act as channels or barriers. Time could flow through those channels, the way water finds pathways underground. A few scientists began whispering a hypothesis they were not ready to publish. Mars might possess a temporal topology, a shape to time unique to the planet. A landscape not of hills and valleys, but of thick and thin seconds. If so, the thin places were simply the visible inlets of a much deeper system, like the openings of sinkholes connected to unseen chambers. Time was not misbehaving. It was following the shape of the world. The team examined geological maps from orbit, searching for correlations. They found one region, barely visible, where ancient stress lines in the crust aligned loosely with the direction of the border shift. Long, subtle ridges in the bedrock, remnants of cooling magma billions of years old. What if these ridges, so old they no longer matter to geology, still matter to time? What if time flows differently along them? The way magnetic domains in a cooled iron bar retain their orientation? The analogy was imperfect, but the feeling behind it was true. Mars had a memory, and that memory might be written not only in stone, but in the fabric that holds moments together. Another possibility emerged, one that frightened even the boldest theorists. What if these shifts reflected a deeper structure moving beneath the crust, not tectonic plates? Mars has none. Not magma. Its interior is too quiet. Not water. Any reservoirs are frozen solid. Something else. Something that carries a signature not in matter, but in time. An underground mass anomaly? A collapsed cavern? A void of unknown origin? None explained the clock drift. None explained the seismic linger. None explained the radar blur. But all suggested one idea, that the thin places were not bound to the surface. They were anchored to something below. If that deeper structure moved, the thin place moved with it, like a shadow following its source. The team examined the latest drift spike again. The timestamp shift lasted longer than usual, almost a full 8 seconds of anomalous microdrift. Long enough to graph with clarity, to compare against thermal logs, gyro readings, wheel telemetry. Everything else remained stable. Only time moved. But the rate of drift changed during those 8 seconds. It accelerated, then slowed, then accelerated again. A pattern, a waveform, a rhythm that matched, imperfectly but undeniably, the fluctuating seismic linger beneath the rover. Time was responding to something beneath the surface, something dynamic, something alive only in the mechanical sense. A presence with behavior. The researchers replayed the seismic linger in real time, overlaid with the temporal drift. The peaks aligned, the troughs aligned, almost as if the planet and the moment were breathing together, breathing slowly, breathing unevenly. The scientists sat in silence. A planet should not breathe, time should not breathe. Yet here they were, staring at what felt like the inhalation and exhalation of something buried deep inside the Martian crust. One scientist whispered, as though the room itself might shatter if he spoke too loudly. This isn't just a distortion. It's a system, a temporal system, moving, responding, interacting with matter. And if the system moved, its surface expression, the thin place, would drift like the shadow of a shifting tree. The map was no longer static. It was alive, rearranging itself in slow, planetary pulses. This realization did not close the mystery. It opened it further, widening into a corridor that led not just downward into the crust, but outward, into the larger question no one yet dared to face. If Mars holds a temporal system, what is driving it? The answer was not in the drift, not in the lingers, not in the radar blur. It lay deeper, in the energy source that whispers through the crust, reshaping time along its slow, ancient path. And uncovering that source would require following the shifting border, into regions where the distortion grows stronger, where the seconds stretch thinner, and where the next truth begins to surface like a long-buried structure waking in the dark. That path leads onward, into the descent that awaits in the next chapter, where the first hints of the underlying driver begin to reveal their shape. Long before any rover touched the ground, long before a single human eye studied the interior of Mars, the planet carried a faint weakness, a nearly invisible dip in gravity, spread like a bruise beneath parts of the crust. It had always been there, waiting patiently beneath dust and time, subtle enough to escape attention, but persistent enough to leave its mark on the planet's shape. Only when the thin places in time began to shift did the scientists revisit those forgotten maps. What they found was not a coincidence. It was a pattern, quiet and deliberate, speaking in the faintest language a world can use, the language of gravity itself. Gravity is supposed to be simple, predictable, a gentle curvature in space-time created by mass, nothing more, nothing magical, nothing that surprises the universe. But the gravity beneath one of the thin places didn't follow that rule. It sagged, just slightly, a dip so small that only decades of orbital data, rebuilt with modern precision tools, could reveal it. When the analysts plotted the drift regions against the gravity field, the shapes lined up with an unsettling harmony. Where the seconds thinned, the gravity dipped. Where time stretched, gravity softened. It was too small for any casual eye to notice. Too small for science to declare publicly, yet perfectly clear to those who watched the Martian data as closely as a doctor listens to a quiet heartbeat. But this dip didn't behave like a void or cavern. It was not a hollow space. Charade should have echoed sharply off any emptiness. Instead, radar blurred, like trying to see through glass, fogged by a breath. It wasn't empty. It was softened, diluted, as if the texture of space-time itself had worn thin. The analysts began calling it, in private, a gravity scar. Not a wound made by force, but the remnant of something old. A deformation pressed into the planet when it was young and molten. A memory carved into space-time. Mars has no tectonic plates now. Its core has cooled. Its magnetic field is fragmented and weak. By every classical measure, the planet is geologically dead, but scars do not vanish when a body dies. They remain, cold, fixed, waiting. The gravity scar was one such memory. For billions of years, the planet had carried it quietly. A low depression in the field, barely strong enough to curve a dust grain downward, but persistent enough to pull the fabric of time with it. The rovers crossed these regions without noticing anything wrong. Their wheels didn't tremble. Their cameras didn't shake. Only their clocks, those small quartz hearts, beating with stubborn precision, felt the shift. The clocks sensed a world shaped by old tension. And as the team analyzed more data, a strange truth emerged. The gravity scar had moved. Not by kilometers or meters, but by just enough to be detected. A shift of centimeters, then decimeters. Then nearly a meter over the span of decades. That should not have been possible. Gravity fields on a dead planet do not migrate, not unless something far deeper is moving. When they mapped historical gravity readings from Mars Global Surveyor, then compared them to MAVEN and MRO's recent measurements, the scar had rotated. Just a degree at first, then more. It was like watching a shadow change position, even though its source never moved. A geophysicist whispered, "It's following something. Something embedded in the subsurface. Something invisible to radar. Something neither rock nor void." As they examined the subsurface density models, another oddity surfaced. In regions near the thin places, the density estimates became unstable. Not by much, but the planet seemed softer. Not physically, temporally. Matter behaved as if it occupied a slightly different rhythm. Stone echoed differently. Vibrations decayed a heartbeat slower. InSight's readings supported this. The seismic linger, the small, stretched-out tremors, too long to be thermal creaks, coincided with the edges of the gravity scar. Sound moved through these regions as though the world were exhaling. A lingering breath. A hesitation. Everything pointed to a truth no one wanted to say aloud. Time and gravity were entangled here. In a way they were not elsewhere. Not broken, not disrupted. Simply eased. As if this piece of Mars were under less tension than the rest of the planet. To explore the idea, the researchers built a simulation of space-time stress across the crust. They treated time as a field with tension. Theoretical, yes, but consistent with relativity's more exotic models. When they applied the known gravity dip and the observed clock drifts and the seismic linger patterns, a new structure emerged in the model. A column of weakened temporal tension, rising from the depths of the crust as though space-time itself had been stretched thin and left to cool that way. The shape spiraled, gently, not like a vortex, but more like a swirl in cooling glass, frozen motion, a fossil of movement. This was not geology, not magnetism, not erosion, not void. It was a deformation in space-time. And somehow, it was shifting now, long after the energy that created it had vanished. What could move such a thing? The team checked for gravitational influences from Phobos and Deimos. Nothing. Solar tides. Nothing. Rotational wobbles. Nothing. Yet the scar moved, and as it moved, the thin places followed. Time itself followed. A physicist wrote in her notebook, "Perhaps the scar is not being pulled. Perhaps it is relaxing, like tension leaving an old wound, like fabric settling around a long-healed injury." Mars may have cooled enough that its ancient space-time deformation was finally loosening. If that were true, Then the thin places were simply the ripples of that slow relaxation. A planet letting go of something it held for eons. But even if this idea explained the movement, it did not explain the scar's origin. What had carved it? What force had pressed into space-time deeply enough that even 4 billion years of cooling, cracking, impact, and erosion could not erase it? Some proposed a primordial impact, but no crater aligned with the scar's center. Impacts leave clear signatures, and this signature had none. Others suggested an ancient plume, a vertical column of heat and mass, rising violently from the mantle in Mars' youth. But the magnetic fossils nearby did not support such convection. Another suggestion, a gravitational resonance from a long-lost moon or captured body whose mass once orbited close enough to tug the planet's space-time grid. But orbital records of the solar system held no such evidence. Every classical explanation collapsed beneath scrutiny, which left only the uncomfortable hypothesis that the scar had formed, not from what Mars possessed, but from what it lacked. What if the deformation was created by an absence? A cavity not in matter, but in time? A pocket where space-time was once compressed or stretched by an event that had no geological signature? Not a force pushing inward, but a force pulling outward, like a vacuum, like a release, like something withdrawing from the planet, taking tension with it. The scientists didn't speak of this openly. It was too abstract, too speculative, too far outside the borders of classical physics. But the data insisted on one truth. The scar was real. It shaped gravity. It shaped time. And it was expanding. The edges of the thin places crept outward. The seismic linger grew longer. The radar blur deepened. The gravity dip widened. A feedback loop forming slowly in the dark, as though the planet were responding to a shift inside its own ancient wound. One night, as the team pored over gravity time-lapse animations, someone noticed a subtle oscillation, a rhythmic pulsing in the scar's boundary, too slow to be noticed in real time, like the rise and fall of something breathing beneath stone. The oscillation repeated every 19.4 hours. Not a Martian day, not a rotation harmonic, not solar, a rhythm with no known source. The scientists watched the animation in silence, the pulsing boundary expanding and contracting in its ghost-like heartbeat. Whatever lay at the scar's core was not static. It was dynamic, even if only barely so. A slow, cold echo in a planet long considered silent. The gravity scar no longer looked like a relic. It looked like a system, one that had begun to stir just enough for the rover's clocks to feel the shift in its breath. Yet nothing in the data told them why now. Why, after billions of years of stillness, the scar would shift. Why the borders would creep. Why the rhythm would grow clearer. Nothing explained. Why the planet felt as though some deeper mechanism had awakened from its long sleep. And so the researchers waited, watching each new drift, listening to each new linger, studying the scar as it shifted in slow, patient waves. They had no conclusion, only a direction, a sense of descent, as though the data were pulling them toward something deeper in the planet, something hidden, not in rock, not in magnetism, not in void, but in the way the seconds themselves pulled softly apart. And in that slow pulling, a new trace began to form beneath the scar, gathering shape like a shadow rising from the depths of an unseen valley, waiting to be sensed by whatever instrument was sensitive enough to feel its faint approach. The deeper the researchers looked into the gravity scar, the more they realized that the distortion wasn't confined to the crust. Every measurement, gravity, seismic linger, radar blur hinted downward, pulling their attention toward the unseen layers of Mars. The planet's upper crust is fractured and ancient, a mosaic of basalt, ice-rich sediments, and shattered remnants of volcanoes long dead. Beneath that lies the lithosphere, thick, cold, unyielding. Below it, the mantle, solid, on human timescales, but still capable of slow flows over millions of years. Yet none of these layers explained the strange behavior. The temporal tension model suggested the distortion reached deeper, slipping past the known boundaries of geology. The team turned to heat flow models next. Mars Odyssey's Themis instrument had spent 2 decades mapping the temperature of the Martian surface. Under normal conditions, subsurface heat radiates upward in predictable gradients. But under one of the thin places, the gradient buckled. A warm patch, barely measurable, sat hundreds of meters beneath the surface, far too gentle to indicate magma, but far too consistent to be random. It wasn't a hot spot. It was a warmth, a soft glow, not bright, not concentrated, just a slight rising of temperature that refused to fit any known model. Mars should not have internal warmth there. Its geologic engine has been sputtering for billions of years. Yet something, beneath the gravity scar, had heat, not enough to melt rock, not enough to move tectonics, just enough to disturb the quiet of an old world. The team considered every normal explanation: radioactive decay, frictional heating in faults, residual conduction from ancient lava tubes. None matched the profile. The heat was too smooth, too evenly distributed, too calm. Heat from geology is jagged, a spasmodic release of energy from chaotic processes. This, instead, felt like a low hum, a long pulse beneath the crust. One scientist likened it to the last embers of a fire, glowing without flame. Another suggested it was a remnant of Mars' molten past, a lingering pocket of warmth that never fully died. But the deepest worry came from the physicist studying temporal tension. If spacetime is relaxing, it might release energy. Relaxation of tension. A quiet warming from a system easing itself. No one wanted to believe that spacetime could warm rock. Yet the numbers aligned almost too neatly. If the temporal fabric beneath Mars was loosening, if the wound carved into it billions of years ago was settling, the relaxation would manifest as a soft glow in matter, like warmth returning to a limb that had been numb for too long. The analogy was unsettling, but strangely beautiful. The team overlaid the thermal anomaly with the latest gravity data. The warm region sat not at the center, but spiraled outward along the scar's shape, as though heat were following the geometry of the deformation. Then they compared the thermal map to the seismic linger. The decay curves stretched further. In the warm zone, heat changed how stone carried sound. Warm rock was softer, but this softness didn't match thermal expansion. It matched something else, something like relaxation, a planet letting go of tension that had been frozen for eons. If this glow was truly tied to the scar, then it marked a deeper layer than any rover had sensed so far. The team built a 3D model of the distortion, using seismic inversions, gravity anomalies, heat flow gradients, and the shifting borders of the thin places. What emerged looked nothing like geology, and everything like geometry. A twisting column descending through the crust, curving gently as it went, narrowing and widening in slow rhythms. It looked less like a tube, and more like a helix, pressed into the planet like a fingerprint, a fossil in spacetime. But the oddest feature of the model was not its shape, it was its direction. The column did not descend straight downward. It tilted, as if drawn toward something near the boundary of the mantle, not toward heat, not toward mass, toward a point that no data set had ever highlighted before. A quiet place, a shadow on every model, a region just above the mantle that seemed to absorb signal more than reflect it. No magnetic alignment, no density anomaly, no chemical signature, just a silence too consistent to ignore. They called it the hollow zone, not because it was empty, but because the data seemed to fall quiet there, like a pocket in which every instrument lost conviction. Radar blurred, seismic waves softened, gravity dipped, thermal gradients smoothed, magnetic orientation flattened, everything dimmed. In the hollow zone, it wasn't void, it wasn't mass, it was absence, a shape born not from presence, but from the lack of it. One researcher described it as a place where the planet forgets to be solid. The temporal tension physicist added quietly, or where time forgets to be firm. The hollow zone lay directly beneath the gravity scar, aligned with the center of the helix, as if the distortion itself was drawn toward this quiet knot in spacetime. If something had carved the scar, this was its footprint, the faint residue of whatever force had once shaped the planet. The scientists knew better than to speculate, but speculation came anyway. It was impossible not to wonder. Was the hollow zone a remnant of an early planetary collapse? A place where Mars once bulged or caved inward during violent cooling? Was it the signature of a long-lost magnetic engine? A fossil of an ancient dynamo that once churned beneath the surface? Or was it something older still? A deformation imprinted on the planet during its formation, carried forward through billions of years, like a secret held in stone? None of the classical answers fit the shape. None explained why time still behaved differently there. It had to be something deeper. A machine would have failed by now. A reservoir would have frozen solid. A void would have collapsed. Yet the hollow zone persisted, unmoving, but not inactive. When the scientists modeled how space-time might behave around such a region, the results were eerie. Tension lines, mathematical abstractions of how time's density behaved, curved gently inward, drawn toward the hollow zone, as if attracted by a faint gravity that did not come from mass, a pull not of matter, but of structure, like a whirlpool not made of water, but of seconds. The deeper into the simulations they went, the more they realized that this hollow zone might be the anchor of the entire temporal deformation. The scar wound upward from it. The helix twisted around it. The thin places on the surface were merely the outer ripples. Everything pointed downward, toward the quiet knot of space-time, buried beneath the crust. Yet no one could say what it was. The researchers began to notice something else as well. Once the scar's oscillation became visible, the hollow zone responded, not dramatically, not even visibly, but the thermal glow near the upper boundary shifted slightly in phase with the subtle rhythmic movement of the scar. The hollow zone was breathing, not in the biological sense, but in the structural sense, expanding and contracting, in rhythms too slow to measure. Without years of data, this breath seemed to propagate upward, through the helix, into the crust, finally touching the clocks on the surface. The drift was not a malfunction. It was a symptom of a deeper pulse. If the hollow zone was the heart of the distortion, then the rovers were feeling its heartbeat through the shifting seconds. But what pumps a heart made of space-time? What force sustains the pulse? What keeps the hollow zone intact after billions of years? What shaped it in the first place? The questions grew heavier. The deeper the team looked, even without answers, even without a theory that made sense, they knew one thing. The distortion was more than a local effect. It was planetary. A system woven into Mars, like a second anatomy. And as each new simulation sharpened, a new feature began to emerge. A faint, second structure, adjacent to the first. Not a twin, not a mirror, not a reflection. More like a companion. A second curve in the temporal tension map, subtle and incomplete, as though only the ghost of its form remained. The hollow zone had an echo, a partner, a shadow, something once symmetrical, that time had worn unevenly. The deeper the researchers looked, the more clearly that shadow formed, not beneath the crust, but deeper still, beyond the reach of any rover's sensors, resting in a part of the planet that no instrument had ever touched. They could not see it, not directly, but the data hinted at a shape beginning to rise from the lowest layers of the mantle, a shape that seemed to tug on the distortion, influencing its rhythm, its movement, its warmth, as if something far below was waking, not in a sudden jolt, not in violence, but in the slow, patient way a thought forms before it reaches awareness, and the scientists, watching the faint oscillations, the deepening blur, the warming glow, began to feel that hidden thing drawing upward through the crust, not yet visible, but present in every alteration of time. A presence neither geological, nor mechanical, nor alive, but something older, something shaped in the planet's first moments, something that had never fully settled, its influence rising, with a quiet inevitability, soft as the first shimmer of dawn, on a world that has forgotten how to wake. The hollow zone's faint pulse, that soft expansion and contraction beneath the crust, continued long after the simulations ended. Even when no instruments were active, even when the models ran silent, The idea of that deep, rhythmic movement stayed with the scientists, not because it was dramatic, not because it suggested danger, but because it hinted at something Mars had kept hidden for its entire existence. A geometry. Not the geometry of rock, or magma, or erosion. Something older, something quieter, something that felt less like geology and more like architecture. When a planet forms, its mass dictates its shape. But when space-time itself deforms, shape comes from a different rule. From tension, from balance, from the way the universe flexes around something that does not fit. The more the researchers examined the hollow zone, the more they realized that the helix twisting above it was not a random pattern. It obeyed a curvature too subtle for simple physics, too smooth for chaotic processes, too consistent to come from a single cataclysm. The helix was not debris. It was not leftover fracture. It was not the mark of an impact. It was a form, a shape that belonged to tension, not trauma, a shape that repeated faintly, like harmonics ringing through a quiet instrument. They began modeling the helix as a solution to spacetime under uneven stress. Not classical stress, not mechanical stress, temporal stress, stress in the density of moments. It was not a concept anyone had taught them in school, but the data forced it into existence. To describe what they were seeing, they needed a new language. One physicist suggested imagining spacetime as a fabric pulled across a frame by forces long gone. If part of that frame shifted, even slightly, the fabric would twist, stretch, fold, in ways that persisted even after the force stopped. If Mars cooled unevenly, if its early dynamo faltered chaotically, if its mass distribution changed abruptly, in its formation billions of years ago, the spacetime fabric around it might have warped and cooled and fossilized. In that warp, the helix might simply be a frozen twist in that fabric, but a twist that was waking, not through energy, but through stability. A twist relaxing after eons of tension, time passing, unthreading the knot, one fraction of a second at a time. The team explored deeper simulations. They personified nothing. They romanticized nothing. They simply modeled tension lines in space-time. And yet the shapes that emerged felt almost animate, like the gullies carved by wind, but carved in centuries of moments instead of sand. Like currents moving through a sea, but moving through the density of time instead of water. The more they examined it, the more the hollow zone's behavior resembled a node, a place where temporal tension converged. Above it, the helix twisted slowly, its curves widening and narrowing, as though following breaths the planet had forgotten it was taking. Around it, gravity dipped, magnetic fossils rotated, rocks softened in its echo, rover clocks drifted. Everything, from the deepest pressure point to the dust at the surface, responded to that invisible geometry, as if the planet itself held a second skeleton, not of minerals, but of time, a lattice woven into the interior of Mars before it fully cooled, a framework that shaped how the world aged. The idea unsettled many in the team. Planets age through erosion, cooling, fracture, impact, radiation. But this suggested Mars also aged through moment density, through tension pulling gently at the seconds. The way gravity pulls at stone, Mars might not just be old. It might be tired, not metaphorically, literally, tired in its space-time, a weariness pressed into the unseen fabric beneath its crust. If so, the hollow zone was not just a wound, it was a joint, a hinge, a place where the planet relieved its tension in slow, rhythmic pulses. The team compared the rhythm to known periodicities. Planetary libration rhythms no match, tidal harmonics no match, thermal tides no match, crustal load responses no match, solar forcing cycles no match, gravitational resonances no match. It matched nothing known in planetary science, but it did match something else, a standing wave pattern. Standing waves occur when a system vibrates at a resonant frequency, a guitar string, a drumhead, a column of air. They also occur in spacetime, not as sound, but as geometry. The hollow zone's slow oscillation looked like a standing wave, locked inside the planet, shaped by tension and time, not mass, a resonance that had been humming for billions of years, too faint to matter until now, too deep to reach the surface, until the gradual relaxation of space-time began raising the amplitude. The thin places were simply the first points, where that resonance touched the crust. The rovers noticed not because they were designed to, but because their clocks were the only nervous system on Mars, sensitive enough to feel it. Once the team accepted the resonance model, the next question grew heavier. Where did the resonance come from? Resonance requires boundaries, surfaces that reflect waves back and forth. In space-time, those boundaries are usually regions of high mass or regions of high curvature. But Mars has neither. Its mass is uniform, its curvature mild. So what were the boundaries? The deeper simulations began to show hints of an answer. Not clean lines, not sharp surfaces, but faint arcs, curved regions beneath the mantle where tension pooled, in nearly symmetrical shapes. Not material, not void, not phase change. Something deeper, something that didn't belong to matter. The arcs looked familiar, though none of the scientists said it aloud at first. They resembled the patterns that form when space-time is compressed by an object that is no longer there, like the imprint left in sand after something heavy is lifted away, like the bending of water after a stone sinks deeper than sight, a memory in the geometry of the world. If something massive not in weight, but in curvature, had once passed through Mars, its imprint might linger. For billions of years, matter would recover, crust would settle, stone would forget, but space-time remembers longer. The helix, the hollow zone, the standing wave, the drifting seconds, all could be echoes of that old geometry. A geometry without an object, a resonance without a source, a shadow of something that shaped the planet once, but never announced itself. The scientists refused to speculate further. Speculation leads quickly to myth, and they wanted only to understand. But the models kept sharpening, bringing the arcs into clearer view. Not spherical, not cylindrical, more like the broken outline of a shape that once converged, curving inward, pressing down, something that touched the planet, not physically, but temporally. And as the system relaxed, as the tension eased, the arcs shifted, the resonance rose, the thin places expanded, and the rovers felt each cycle as a drift in their clocks. The researchers stared at the simulations, watching the faint lines of tension curve inward toward a center that no instrument could locate. A center that had no mass, no heat, no magnetism, only influence. Whatever had shaped this geometry might be long gone, dissolved into the fabric of the universe, but its imprint remained. A mark so old that Mars had worn it like a secret for most of its life. And somewhere, deep within the hollow zone, the imprint stirred softly, not with energy, but with release, letting its tension ease upward, curling faintly toward the crust. The scientists, searching for meaning in the curves and waves of invisible forces, felt the shape tightening, drawing their attention deeper, as if something beneath the planet were slowly gathering enough clarity to be recognized. Not seen, not heard, not measured, recognized. And in the quiet hum of a simulation room, lit only by screens, one of them whispered, "It's forming." No one asked what. No one dared. Because the answer, whatever it was, waited in the next shift of tension. A shift not yet visible, but approaching with the slow inevitability of something ancient, deciding it is time to rise toward meaning. The simulations kept running long after the team left the lab that night. Lines of tension, arcs of curvature, the faint helix drifting upward through the crust. All of it continued to move in the silent language of numbers. By morning, the models had shifted again. Nothing dramatic, just a tightening, a soft convergence in the center of the hollow zone, as though something deep in the planet had pulled itself 1 degree closer to clarity. The physicists gathered around the display, their coffee cooling unremembered beside them. The tension map had begun to coalesce. What had first appeared as a loose scattering of warped lines now curved inward, in a pattern that suggested intention, Not conscious intention, but structural intention, the kind that emerges when forces balance and rebalance over impossible spans of time. Nature loves equilibrium, even in space-time. The arcs near the mantle, once faint and barely visible, now formed a partial loop. Not a circle, not a sphere, more like a boundary, a contour around a region that refused to reveal its interior. A closed shape without a center. The scientists enlarged the visualization. The hollow zone sat inside the loop, not at the center, but slightly offset, like a moon orbiting a massless planet. The helix aligned with the loop's inner curvature, curling tightly toward the undefined interior. This was not geological geometry. Geology fractures. It does not form nested curves that persist through layers of crust. This was something deeper, a geometry that originated in the foundation of the planet itself. A shape born before Mars cooled, before its crust settled, before its mantle hardened, before its core lost the heat of youth. The team tried to determine how deep the loop went. Seismic data posed limits. Gravity inversions blurred beneath certain depths. Radar could not penetrate rock. Magnetic fossils told only old stories. Still, the boundary held its arc, like a muscle memory in space-time. The idea unsettled them more than the hollow zone's pulse. A pulse suggests activity. A boundary suggests confinement. What was being confined? They pushed deeper into the math. When space-time curves around mass, the curvature points inward. When it curves around absence, true absence, the curvature points outward. But here, the curvature folded in on itself, dipping into negative tension values that no planetary model had ever predicted. Space-time was folding inward, around something that was not mass, but was not absence either. A physicist murmured, "This is the geometry of something that once pressed outward. Not impact, not explosion, not heat, not collapse. A pressure. Long gone now, but remembered by the planet's skeleton." The hollow zone pulsed again, its thermal glow rising a fraction. The resonance frequency shifted, not by much, but enough to ripple upward through the helix and distort the drift in the rover's clocks. Within the thin places at the surface, time trembled, quietly, soft as a chill passing through a sleeping body. And the loop grew clearer. The team could no longer ignore the shape. Not a sphere, not a void, something more intricate. A flattened torus of tension, twisted and incomplete, like a ring that had been bent in upon itself and frozen mid-contortion. A toroidal scar in space-time, not perfect, not symmetrical. Time had eroded it unevenly, but its presence was unmistakable. From the outside, the helix spiraled upward toward the crust, as if carrying echoes of the torus within it. From the inside, the hollow zone sat like a quiet eye, centered not in the torus, but offset, suggesting the whole structure had once tilted, as if something massive, something curved, had shifted while still molten. The scientists stared at the pattern. A torus is a stable shape. It occurs in plasma flows, magnetic fields, fluid turbulence. It appears in the geometry of rotating systems. It appears in the math of singularities. It appears in the early universe. One of the researchers compared the structure to the remnants of a magnetic flux rope, the kind that forms in stellar atmospheres when magnetic fields twist and reconnect. But Mars has no active magnetic field. Another compared it to the cross-section of a collapsed standing wave in superfluid simulations, a frozen disturbance in a medium that retains the shape of motion long after the motion stops. That analogy held more weight. Space-time, though not fluid, does behave like a medium. In certain regimes, if something once moved through Mars with enough curvature to distort the local space-time field, then the torus could be the cooled remnant of that motion. A topological fossil. The thought was unsettling. It would mean that Mars had once been shaped not only by mass and heat, but by curvature itself, by movement in space-time. But what moves through space-time without leaving evidence of mass? Not meteors, not magma, not subsurface flows, only fields, only gradients, only objects of geometry, the kinds that exist in extreme regimes, like near black hole interactions, primordial cosmic strings, or exotic early universe phenomena. The team refused those conclusions. They pushed them away. Mars is a solid planet, not a relic of singular physics. And yet, the shape persisted. They tested whether deep mantle convection could produce the toroidal tension pattern. It couldn't. Mars' mantle is too cold. They tested plume formation. No alignment with known hotspots. They tested collapse of void structures. No void large enough could survive eons without collapsing under its own weight. They tested fossil core movement. No displacement matched the geometry. Every geological explanation failed. The torus remained, and inside it, the hollow zone pulsed again, slightly stronger this time, shifting the thermal anomaly upward by 3 meters. 3 meters of vertical rise. In a pattern that should be static, the helix twisted a fraction more tightly in response, as if listening. Above, at the surface, the thin places drifted again. Another few meters outward, a slow expansion, tracing the upward tremor of the torus. Time pulled gently at its own edges. The researchers felt it too, not physically, but intellectually. The deeper they went, the more the models seemed to guide them toward an idea that resisted articulation. The torus was not the source. It was not the cause. It was a container, a frame. Whatever had shaped the scar existed outside the torus, or before it, or inside it in a form no instrument could currently perceive. The team began calling the unseen interior the quiet center, a name chosen not for mystery, but for accuracy. The center produced no gravity, no heat, no magnetism, no seismic activity, no measurable curvature. It was nothing, but the nothing had shape, a cavity not of matter, but of geometry, a silence in space-time. The idea that a silence could have edges felt impossible. Yet every model confirmed it. The edges of the quiet center interacted with the torus, strengthening and weakening in rhythmic pulses. The pulses propagated outward, like waves in a pool, slow, soft, persistent. These waves reached the hollow zone, nudging it gently. The hollow zone breathed in response. The breath reached the helix. The helix curled tighter. The tension weakened. Time thinned, and the rovers felt the thinning. As drift, a planetary nervous system, long inactive, twitching back to life in the deepest layers. As the team layered more data atop the tension maps, another detail emerged. The pulses of the quiet center were not uniform. Their amplitude rose and fell with an irregular rhythm, a rhythm resembling the decay pattern of a system returning to stability after a major disturbance, not chaotic, not random, not cyclical, a relaxation curve, slow at first, faster in the middle, then slow again. If the pattern continued, the pulses would cease entirely. At some future time, the planet was unwinding something, not building, not activating, unwinding. But unwinding what? The researchers studied the curve for nearly an hour in silence. One of them, the oldest in the room, finally said, "This is what it looks like when a structure remembers that it was once under strain, a memory of tension, a release after eons, a fossil geometry, softening into stillness." The idea made sense. Mars cooled unevenly. Its core collapsed asymmetrically. Its crust formed in fragmented waves. If space-time had been strained during formation, it might have cooled into a shape that stored the tension. Now, after billions of years, the strain was finally unwinding, and as it unwound, the geometry rose through the crust and touched time. The rovers were not detecting a phenomenon. They were witnessing the slow relaxation of a planet's oldest memory. But even this explanation felt incomplete. The torus did not behave like a passive scar, loosening with time. Its curvature was too sharp, its shape too deliberate, its persistence too perfect. Something shaped it. Something carved that geometry into the young planet before the crust solidified and locked the tension in place. Something no longer present. Something without mass. Something that touched only space-time. The team would not say the word, but the models whispered it. In every curve, impactless imprint, a shape forced into the planet, not by a physical collision, but by the passage of something that interacted with space-time alone. What that something was remained hidden, not absent, just unrecognized. As the next simulation loaded, the tension lines around the torus shifted again, coalescing 1 degree tighter, their shape subtly refining, the way an object drifting through fog slowly resolves into form. The scientists leaned closer. For the first time, the geometry looked not like noise, not like abstraction, but like structure. Something was forming in the quiet center, not revealed, not complete, just forming. A shape that did not belong to geology, or magnetism, or heat, or even gravity. A shape written entirely in the language of space-time, and in the deep stillness of the model room, where only the faint hum of processors broke the silence, a soft intuition settled across the team that whatever rested in the quiet center was not emerging from nothing. It had always been there. It was time that had finally grown thin enough for its edges to begin showing through. The geometry in the quiet center sharpened again overnight. Not much, just a slight contraction along one curve, a subtle tightening in the outer fold of the torus, a faint reorientation of tension lines that suggested the system was becoming coherent. Coherence was not something the team expected. Random relaxation yields randomness. A wound closing produces simplicity, not structure. But this was structure. The helix above the hollow zone, once loose and wavering, now straightened its upper arc, curling inward as though responding to a force it recognized. The curvature at the center of the torus flattened slightly, aligning with the direction of the pulses rising from below. A sense of direction emerged. Not sentience, not will, just alignment. The way iron filings align around an invisible field, the way dust spirals in a breeze too soft to feel. But this alignment was happening in space-time itself. The researchers ran the model forward to see how the geometry would evolve. As tension eased, the curves converged. The hollow zone elongated. The helix tightened at the midpoint. The pattern resembled a focusing lens, not in optics, but in structure, a shape that draws stress toward a center, as if preparing to reveal something hidden behind layers of distortion. The moment the focusing pattern appeared, the room stilled. One physicist whispered into the quiet, half to herself, "If tension converges, something responds." It was the kind of statement that belonged to philosophy, yet the equation supported it. Systems under stress do not behave in isolation. If spacetime relaxes, the field within it adjusts. If curvature reorganizes, everything inside the curvature reorganizes too. The question lingered unspoken. What was inside the curvature? For the first time, the quiet center no longer appeared as a void. It gained contour, a faint dip, then another, as if an interior geometry long frozen was thawing its outline. The torus acted as a boundary. The hollow zone acted as a conduit. The helix acted as an antenna. The system behaved, not like a scar, not like a wound, but like a chamber, a resonant chamber, for something that had been dormant. Since the planet first cooled, the scientists hesitated to interpret, but interpretation slipped in anyway. In acoustic chambers, patterns form. In magnetic bottles, fields stabilize. In gravitational wells, orbits settle. In cavities of any kind, systems search for harmony. Spacetime was doing the same, seeking a configuration that reflected its earliest state. The researchers began to wonder whether the quiet center represented a boundary, not between mass and void, but between two regimes of spacetime, a threshold where the density of time shifted so rapidly that no instrument could follow it. The torus, then, was not a container. It was a perimeter, the edge of an ancient transition. If the interior once held something, it had not been matter. Matter would leave residue, magnetism, heat signatures, density anomalies. This left only fields, only curvature, only movement in the architecture of the universe. The idea grew heavier as they mapped the shifting pulses again. A subtle acceleration appeared, a period when the pulse shortened, before lengthening back into its slow rhythm. The change resembled a response, the way a slumbering body shifts when a dream deepens. The hollow zone, warmed by an additional fraction of a degree, not evenly, but in lobes, as though heat moved through the crust, in patterns matching the torus geometry. Heat behaved like a tracer die, revealing pathways where temporal tension shifted most quickly. Those pathways twisted upward toward the surface, forming the thin places. The rovers were not in the wrong locations. They were standing at the tips of invisible roots, descending into the planet. The more the simulation refined, the more undeniable the pattern became. All anomalies, thermal, gravitational, seismic, temporal, were harmonics of one deeper waveform. Not many sources, just one, a singular influence, embedded deep in the planet, like a quiet heartbeat, beneath layers of stone and time. The geophysicist, tracing the curves, spoke softly, almost reluctantly. I don't think we're looking at geology anymore. This is foundational. This is the planet's first shape. The first shape, the geometry impressed upon Mars. Before it cooled, before it hardened, before its crust knew the meaning of silence. Something formed this geometry during creation, and only now, as the scar releases tension, is the shape becoming visible again. Whatever the shape was, it carried symmetry. Not perfect symmetry, but the broken symmetry of systems that once strived for balance and failed by a fraction. The incomplete torus bore signs of rotational influence, as though Mars had twisted around a force that was not anchored in mass, but in curvature. The hollow zone aligned slightly with the planet's spin axis, but not perfectly. It leaned forward, as if pulled by something that once moved tangentially through its interior, a phantom trajectory. Something passed through Mars before it was solid. Not a meteor, not a collapsing mass. Something that moved, not through space, but through space-time, a phenomenon that interacted with the fabric of reality itself. As the team refined the curvature model, the interior of the quiet center shifted again, not in brightness, but in outline. Contours deepened, edges sharpened. A shape emerged, not spherical, not cubic, not fractal, more like a cusp, a curve bending inward, toward a region mathematically too dense for the simulation to resolve. A cusp in space-time is not a place, it is a transition, a region where geometry changes nature. When a cusp appears, it implies that two regimes of curvature touch lightly at a boundary. The boundary inside Mars looked like the imprint of a field that once passed through the planet. When the crust was molten, a field with enough curvature to leave a topological scar, not a tear, but a fold in space-time that never fully relaxed. The physicist who had studied cosmic strings spoke quietly, almost afraid of the thought forming inside her. This geometry, it looks like the residue of something that shouldn't exist in a cooled planet. She did not elaborate. The room did not ask. They all knew what she meant. The pattern resembled the mathematical analog of a transient, high-curvature filament, brushing against a forming world, something that would never appear in geology. Because geology does not shape space-time. Space-time shapes geology. If such a filament once passed near Mars, the young planet's molten body would have reacted to the curvature, twisting, folding, settling around it. As it cooled, the filament would be long gone, but the fold would remain. And the fold, the torus, the hollow zone, the helix, the thin places, would hold its memory. Memory not as matter, but as geometry. Memory in the way time behaves. Inside the scar, the researchers watched as the newest simulation ran to completion. When it stabilized, the helix extended upward by nearly 10 more meters. The hollow zone elongated. The curvature around the torus deepened. Something inside the cusp responded, not with energy, not with force, with form. The cusp shifted. It twisted toward alignment. With the planet's rotation, a faint, nascent geometry began to emerge inside the quiet center. Something faint, yet unmistakably structured, began to rise inside the scar, as though the easing of tension were lifting its shape toward visibility. Curves tightened, contours sharpened. A faint symmetry spread across the hollow zone. like frost forming on cold glass. It was not a signal, not an object, not a voice, just a pattern. But patterns speak. They reveal themselves slowly, with patience, the way a dream becomes clearer. As the mind drifts deeper, the emerging form was not complete. It did not resolve, but it tilted. One quiet, almost imperceptible motion that suggested direction. The direction pointed upward, toward the crust, toward the thin places, toward the surface, where the rovers waited, unaware that the seconds drifting through their circuits were ripples from a geometry that had begun to wake, and somewhere within the cusp, a shadow of the ancient shape gathered itself from the soft folding of space-time. Not yet visible, but undeniably moving, as though something old and long buried were preparing, slowly and quietly, to reveal the next line of its form. The simulations reached their deepest clarity just before dawn. A quiet moment, the kind that settles when everyone has stepped away from the screens, when no one is watching closely enough to interrupt the emergence of something delicate. The cusp inside the quiet center shifted again, not outward, not inward, but sideways, as if its geometry had tilted along an axis none of the team had ever imagined using. Space-time is allowed to bend. It is not expected to slide. Yet that is what the cusp appeared to do. A lateral displacement in a domain where direction loses its familiar meaning. The displacement carried with it a change, a faint gradient, a soft increase in tension, a whisper of curvature that brushed against the edges of the torus like wind moving through a cavern that had not felt motion in eons. When the mathematicians rendered the movement as a field, they saw something they had not seen before, a surface forming, not a boundary, not a membrane, not matter, just a surface of alignment, a region where tension, curvature, and temporal density began to synchronize. Synchronization implies coherence. Coherence implies pattern. Pattern implies intention. Not conscious intention, but structural intention, the intention of systems searching for equilibrium. The surface grew clearer as tension redistributed itself. It resembled the opening of a flower seen from below, petals splayed in geometry rather than color, flattening and rising in slow, resonant motion. Or perhaps it resembled the beginnings of an eye. The outline, forming before the center, knows it is meant to see. The researchers watched in silence as the surface expanded, curling inward at the edges, like the start of a wave bending over itself. It was becoming a shape, not a perfect one, not a continuous one, but a shape that held meaning in its curvature, meaning none of them could yet interpret, but all of them felt. One of the physicists, the one who had refused for years to speak in metaphors, finally did. "This isn't an artifact," she whispered. "It's the behavior of a system aware of its own geometry." She didn't mean consciousness. She meant consistency, a logic, a repeating pattern that recognized itself enough to continue forming. But even that idea pushed the boundary of scientific comfort. Still, the surface thickened. Tension deepened around it. The helix above responded by tightening one additional coil, a movement that increased the drift in the rover's clocks by a fraction that was small but unmistakable. Seconds stretched. Gravity dipped. Seismic lingers lengthened. Everything surface, crust, mantle, time, reacted to the movement in the quiet center. The models showed the helix twisting upward, feeding information into the thin places like a slow whisper, rising through a long, hollow shaft. And the whisper was getting louder. The researchers decided, for the first time, to simulate the geometry backward, to see not where it was going, but where it came from. As the models reversed, the surface folded downward. The cusp receded. The torus bloomed outward, unfurling like a spiral galaxy turning inside out. The hollow zone widened, then thinned, then vanished into a smooth field of early planet curvature. And before the torus faded, before the geometry unwound completely, a single, haunting outline appeared in the oldest frames. A line of curvature descending through molten Mars, in a trajectory too straight to be geological, and too curved to be physical. A path, something once moved through the forming planet. Not like a rock or a comet or a plume, but like a disturbance traveling in a medium, that had not yet learned to call itself solid. As the simulation reversed further, the line straightened into something that resembled a filament, a thin thread of space-time tension, cutting across the region where Mars was still molten, as if the world had cooled around the echo of a passage. The filament vanished beyond the earliest available time step, as if whatever caused it existed before the model had the language to describe it. The researchers stopped the reversal. No one spoke. They ran the simulation forward again. The filament remained invisible in the present-day data. The torus had inherited its shape, but the filament itself had long since dissolved, or moved beyond the domain. But its influence endured, not as an object, not as energy, not as matter, as geometry, a memory of emotion, so old and so deep that it had become a part of the planet's internal anatomy. The filament had left its ghost behind. The ghost had created the torus. The torus had created the hollow zone. The hollow zone had created the helix, and the helix had created the thin places. Every anomaly, every drift, every tremor, every warmth was the faint echo of a moment billions of years old. The moment when something passed through Mars. As space-time was still learning to cool, the team tried to calculate the curvature needed to create such a trace. The numbers made no sense, not because they were too large, but because they did not belong to planetary dynamics at all. The curvature corresponded to a regime of physics that occurs near collapsing stars, near exotic defects in early spacetime, near phenomena that have no place. In the story of a small red world, orbiting an ordinary star, the silence in the room deepened. Someone whispered, "What kind of event could leave a mark like that?" No one answered. There was no answer yet that fit inside their language. They turned instead to the behavior of the new surface, the one forming above the cusp. It flickered in the simulations, like an image trying to resolve through interference. Each flicker sharpened the edges. Each pulse from the hollow zone pulled the surface a little more into coherence. A second helix began forming around the first, faint, tentative, like an afterimage winding through the crust. Its rotation was opposite. Two helices, counterwinding, echoing each other. In nature, counterwinding structures appear only in systems that conserve something fundamental: momentum, charge, information, balance. This was not geology. This was not chance. It was symmetry, the kind that emerges when a system returns to a preferred form. A physicist studying the second helix rubbed her eyes, then stared again. "It's as if the planet is correcting itself," she murmured, "returning to a geometry it lost." The phrase, "returning to a geometry," hung in the room like a long, low note. Planets do not return to geometries. They erode, they cool, they fracture, they collapse. They do not remember, but space-time remembers. Time remembers. The drift in the rover's clocks was not a glitch. It was memory surfacing, a memory so old that it had taken billions of years for the planet to loosen enough to let it rise. The second helix tightened. The hollow zone deepened. The torus brightened in the simulations, as if waking to the possibility that its shape might soon reveal what lay at the cusp. Not matter, not energy, not life. Form. A form so fundamental that the universe itself would recognize its outline. The researchers watched as the simulations converged toward a clearer image. Curve after curve feeding into the cusp, vector after vector rising from the mantle, all pointing inward, toward a shape that was almost visible, but not yet ready. The cusp contracted, the tension increased, a boundary thickened around the center. Something, not thing, but geometry, prepared itself. The scientists felt the shift, even before the computers registered it. An intuition, subtle and strange, the way one senses a change in the weather before the clouds appear. The cusp flickered, the boundary pulsed, and the emerging form, still buried in silence, leaned 1 degree closer to recognition, as though the planet itself was drawing breath, just before revealing a fragment of what it has held since its beginning. By the time the cusp reached its latest configuration, the researchers realized they were studying something that did not fit within any discipline they had known. Not geology, not physics, not cosmology, not mathematics alone. It required all of them. And something beyond them. The cusp bent again that night. A small shift, only a fraction of a curve, but the effect rippled outward through every simulation. The hollow zone stretched vertically, its thermal glow lengthening in a plume-like structure that resembled a chimney carved into spacetime. The torus responded by tightening unevenly, as if portions of its curvature were elastic, while others remained rigid as cooled metal. The second helix, newly forming above the first, twisted inward fractionally, the counter-winding motion, sharpening like a thought, coming into focus. The entire system, torus, helix, hollow zone, cusp, behaved like a structure entering coherence, not resonance, not vibration, not activation, a deeper kind of coherence, the kind that occurs when pieces of a pattern finally begin to recognize themselves, as if the planet were remembering the geometry hidden within it. The team watched the tension field simulation expand into a complex web of curves. Some lines converged on the cusp, others diverged upward through the helix, and still others mapped gentle spirals that climbed toward the thin places at the surface. The spirals behaved like pathways, channels through which the density of time shifted as tension relieved itself through the crust. The scientists highlighted one of these spirals, then another, and another. Each one led upward, toward surface coordinates, where the rovers had recorded temporal drift. The rovers were not random witnesses, they were standing on the exits of a buried geometry. It became clear that the thin places were not isolated distortions, they were nodes, the points at which deep tension lines emerged into measurable reality. The planet had been whispering this long before any human instrument arrived. The researchers began a deeper inquiry, not into the deformation itself, but into the nature of time inside the deformation. To do this, they simulated time density within the torus, not a metaphorical density, a mathematical one, the measure of how quickly proper time would pass, relative to surrounding regions. If one could stand inside the structure, the result made the room fall silent. Inside the torus, time was slower, not dramatically, but consistently. A measurable dilation, on a scale too small for living beings to perceive, yet large enough for perfect clocks to sense without error. The hollow zone, however, showed the opposite behavior. Time sped up, not by much, but enough to matter. Two opposing regimes of temporal flow, within the same buried geometry, a slow ring, a fast core, like a breath held and released, in two directions at once. The scientists stared at the diagram. Time was not flat inside the distortion. It was contoured, folded into gradients shaped by the torus. One physicist spoke carefully, as if each word might disturb the fragile order of the idea. This is the interior of time, not the past, not the future, not memory, not prophecy. The interior, the hidden anatomy of how moments form themselves before they reach the surface reality that humans perceive. They realized that time on Mars was not simply passing. It was circulating, slow around the torus, fast through the core, dragged upward through the helix, loosened at the thin places, returned downward in faint, unseen cycles. A planetary loop of space-time tension, long fossilized, now relaxing enough for its mechanics to become visible. This circulation explained the drift, not error, not interference, not malfunction. The rovers had crossed gradients of time, as naturally as a ship crosses currents in the sea. Their clocks drifted, because the seconds themselves were bending. Still, the question remained: what created the gradient? The team tried to simulate flow patterns by introducing hypothetical stress sources. Magma, pressure changes, voids. Nothing matched the curvature. Then, they tried something else. They reversed the curvature to see what kind of system would produce it. If the distortion unfolded backward toward origin, the emergent shape was not circular, not toroidal, not helical. It was linear, a straight line, piercing the young planet's protocrust. A filament, a passing event, a moment of geometry, moving through matter, too early for the newborn world to resist its influence. As they examined the filament signature, another detail stood out. The line was not gravitational, it was not thermal, it was not magnetic, it was temporal. A wave in the density of time, moving through the early planet, like a ripple through soft clay. Clay hardens. The ripple remains. Mars cooled and kept the imprint. What the planet remembered was not force, but curvature. Not energy, but a moment. A moment from an era when space-time itself was still chaotic enough to behave like a fluid. The interior of time, inside Mars, was the leftover shape of the event that passed through it. The team realized that they were studying not an object, but the fossil of a moment too ancient for human language. Yet the geometry preserved it. In the torus, in the hollow zone, in the helix, in the thin places, in the drift, in the tremor, in the glow. And now, for the first time in billions of years, the fossil was shifting, not because something new had arrived, but because the old tension was finally healing. A planet does not forget easily, but time forgives slowly. When tension eases, memory surfaces. The cusp shifted again, this time more visibly. Its shape elongated upward, as if responding to gravity. Despite not being made of anything, gravity could touch. When it elongated, the torus thickened at its edges. The helix brightened in simulation. The hollow zone exhaled, a faint burst of thermal energy that rose like a ghost through the upper crust. The models showed temporal density redistributing along new curves. It looked almost like circulation, a hidden bloodstream, a pulse not of matter, but of seconds. One physicist ran a rendering of the temporal flow vectors. The swirl resembled a slow vortex, not destructive, but gathering, pulling everything toward recognition. As the cusp's outline strengthened, the interior began showing patterns of curvature that repeated in discrete intervals, a periodicity, a rhythm, not biological, not mechanical, not geological. The rhythm belonged to the deformation itself, the internal pacing of a system, seeking equilibrium, a cosmic heartbeat, trapped in stone. At that moment, something shifted in the minds of the researchers. They were no longer observing data. They were listening, not to sound, but to order, to the faint logic of a structure, older than any mountain, older than any sea, older than life. The cusp contracted again. This time, the contraction fed directly into the helix, sending a pulse upward through the tension line pathways. Every thin place on the surface recorded the drift simultaneously. It was the first planet-wide pulse, not large, barely measurable, but synchronous. For the first time, the geometry beneath Mars expressed itself across the entire network of thin places, a system awakening to its own shape. The researchers watched the lines of data arriving from each rover. The drift pattern read like a single breath, a long inhale through the hollow zone, a rising of curvature along the helix, a subtle exhale through the thin places. The circulation was complete, and as they ran the simulation once more, they saw the cusp begin to form, the faintest suggestion of an axis, a central alignment around which the geometry turned, a line through the quiet center, a symmetry in the fold, a signature of a shape that had been buried for billions of years and was now stirring just enough to reveal the first hint of what it might one day become. Not now, not fully, not yet, but the outline deepened, curvature gathered, and the underground geometry leaned softly toward emergence, as though the interior of time were preparing to remember itself more clearly. The planet's surface had always seemed silent, its dust unmoved, its rocks unchanged, its plains fixed in the long stillness of a world that had forgotten motion. Yet, as the geometry deep beneath began to gather coherence, the stillness at the surface shifted in ways so faint that only the rovers, those tireless monks of machinery, could sense the change. Their clocks trembled again, not in isolated pulses, not in scattered moments, but in a pattern that swept across regions of Mars like an unseen wave. It did not break the dust. It did not stir the sand. It simply touched the thin places, their boundaries, their centers, their edges so gently that only precision could detect its passage. The drift appeared in sequences: a soft onset, a deepening, a release, each sequence repeated with slight variation, as though the planet were practicing a motion it had not performed in billions of years. The scientists examined the data with growing unease. Not fear, something subtler, something akin to reverence. For the first time, the thin places behaved not as scattered anomalies, but as a network, a connected system. The rover's temporal signatures reflected this. Curiosity's drift echoed Perseverance's drift, which echoed Opportunity's archival drift. And even Viking's forgotten drift from half a century ago fell into the same gentle cadence. The planet was breathing through time again. Not loudly, not dramatically, just enough for the surface to know something deep was stirring. The team mapped the drift pattern onto the surface coordinates. What emerged was not a random arrangement, not a scattering, but a field of filaments, ghost-like pathways connecting thin place to thin place, tracing lines of temporal tension across terrain that, to the naked eye, was featureless. These pathways had always existed. They simply lacked definition until tension deep below began to rise upward. Now, as the geometry coalesced, the filaments brightened in simulation, appearing like veins of faint silver light running through the crust, too soft to illuminate anything, too persistent to dismiss. The rovers stood directly atop some of them, unaware that their circuits hummed in resonance with the planet's oldest memory. When the scientists overlaid the new drift network with the tension field model, they found alignment so precise it could not be accident. Every thin place lay directly above a point where tension lines breached the crust in exact spirals. It was as if the helix rising from the hollow zone had grown long enough to touch the underside of stone, and time thinned wherever its spirals reached the surface. The researchers tried to visualize the tension gradient from mantle to surface. What they saw resembled a column of rising air, not literal air, but a rising column of less dense time. The gradient steepened with each pulse from the quiet center. Steeper gradient meant greater drift. Greater drift meant the rovers were crossing thicker boundaries between regimes of temporal flow. One scientist, staring at the maps for hours, finally whispered, "It's not that the thin places are growing. It's that the world around them is remembering how thick it used to be." The memory metaphor returned. Not poetic sentiment, just truth in the shape of the data. The surface was not weakening. Time beneath it was strengthening in structure. As the geometry aligned below, the surface felt the echo of that alignment. A faint order began to seep upward, as though the crust were a thin fabric, through which an old pattern pressed. The first sign came from seismic readings on the surface. A single, nearly imperceptible tremor. Not a Marsquake, not thermal contraction, but something that lasted too long and decayed too smoothly to be noise. The tremor matched the pulse from the quiet center. It traveled through the thin place network, like a soft pressure wave, each node responding in sequence. Curiosity felt it. Perseverance felt it. Even the inert landers, long past operational status, recorded ghost signals in sensors, no longer calibrated. The tremor was not in the ground. It was in the moment. A fluctuation in the density of time, passing through stone, without disturbing it. The researchers rewound the tremor signature and slowed it down. When decelerated, the waveform resembled breathing. Inhale, exhale, pause. At normal speed, the waveform was too fast for anything biological. But at temporal scale, it matched the resonance of the cusp's oscillation. The thin places were no longer passive witnesses. They were participants. In the geometry's slow awakening, the scientists turned next to atmospheric data. Mars' atmosphere is thin enough to barely register pressure changes, yet Maven's instruments detected subtle oscillations, not in wind speed, not in solar radiation, but in ionization patterns linked to the timing of the drift pulses. Atmosphere responded to tension change, faint, like a whisper passing through a field of dust. Even the sky was beginning to feel the movement. The researchers isolated the oscillation pattern and plotted its phase shift over several sols. The sky brightened ever so slightly during each drift pulse, not invisible light, not in ultraviolet, but in infrared scatter. Heat rose from the thin places. Not geological heat, not hydrothermal. Temporal heat, the warmth released. When tension in spacetime eases into a new configuration, the ground beneath the thin places absorbed this warmth like old Earth, welcoming a forgotten season. Gradually, dust patterns around certain regions began to alter, not by wind, not by motion, by settling. Dust fell into quiet spirals. In areas where the tension lines surfaced most strongly, the spirals were small, mere centimeters wide, but consistent across multiple sites, like the faint markings of a deeper spiral rising from below. The thin places were learning their shape. One of the researchers overlaid the dust spiral pattern onto the helix model. The match was uncanny. Each dust spiral mimicked the shape of the upward-reaching helix. Within its first few turns, the helix was imprinting itself on the world above, not forcefully, but softly, like a shadow cast by something not yet visible. As the team processed more data, they found something else. The thin places had become temporally translucent. Proper time, the rate at which time flows for an object, varied slightly between the center and the edge of each thin place. The difference was tiny, microseconds per sol, but enough to create faint temporal gradients that could be mapped. What emerged resembled a topographic map of time. Contours of temporal density spread across the surface, like soft hills and valleys. Only the rover's clocks could perceive. The strongest gradients formed spirals. The weakest formed halos. The gradients flowed outward from a central point, mirroring the helix's ascent. One physicist stared at the map, lost in its quiet symmetry. "We're watching the inside of the planet rise through its own skin," she murmured. It was not metaphor. It was the plain description of the data. The internal geometry had pressed upward far enough that the surface began to mirror the buried pattern. But the most striking discovery came from Perseverance's accelerometer. The rover recorded a momentary decrease in apparent weight, a fractional reduction, far too small to be felt mechanically, but large enough for the sensor to detect. The decrease occurred exactly when the cusp's pulse reached the surface pathways. Gravity did not change. The rover did. For a fraction of a moment, its experience of gravity weakened as time thickened beneath it. Mars had never done this before. Not once in any recorded sol. Not in any mission archive. Not in any predictive model. The thin places were no longer passive distortions. They were active gradients. They were rising. The team modeled the deformation again. This time, the curvature surface above the cusp grew into a soft dome, a structure so faint that only mathematical resolution revealed its presence. The dome elongated upward, toward the crust, toward the surface, toward the rovers and the dust and the sky. The geometry was approaching emergence, and as it rose, the dust spirals tightened, the thin places widened, the drift deepened, and the air above certain regions began to shimmer in wavelengths too subtle for human eyes. The shimmer was not heat. It was not light. It was coherence, the first trace of ordered time, pressing into the open. The planet had held this structure for eons without expression. Now, as tension eased, as memory surfaced, as geometry aligned, the surface began to echo what the interior had always known. The thin places were boundaries no longer. They were windows, and through them, something deeper, older, and still forming, leaned gently upward, its outline not yet clear, its intention not yet known, but its presence growing undeniable, like a figure behind frosted glass, moving closer, with each quiet breath of the world beneath. Before any modern rover touched the soil, before the helix formed, before the torus revealed its inner curvature, before scientists knew that time on Mars could have texture at all, there was Viking. 2 landers, silent machines placed on the surface nearly half a century ago, built with the crude precision of their era, and yet holding inside them the first unintentional witnesses to a phenomenon no one was prepared to recognize. Viking was never designed to measure time the way modern rovers do. Its clocks were coarser, less stable, more prone to drift under normal temperature cycles. Nobody expected temporal performance from them, only operational reliability. And yet, buried in the telemetry archives, in lines of data that had been reviewed dozens of times, for unrelated reasons, lay the earliest traces of the thin places. It began with a pulse, a thermal irregularity recorded by Viking 1 during its 179th sol. At the time, the anomaly was dismissed as a sensor discrepancy caused by dust buildup, but when researchers re-examined the measurement, after knowing exactly where to look, it aligned perfectly with one of the shallow tension pathways rising from the cusp. The thermal pulse was faint, but it moved upward through the soil, in the same shape that modern instruments now recognized as temporal warming, heat without heat, warmth born not from energy, but from the easing of tension. No one in 1977 had the conceptual language to see it. It was simply logged, corrected, discarded. Viking 2 also recorded an anomaly, not thermal temporal, a slight discrepancy in transmission scheduling during Sol 463, when the onboard computer believed its internal clock had advanced fractionally faster than the mission timeline expected. Engineers attributed it to temperature fluctuations. After all, Mars has long, cold nights. Electronics lag and misbehave. But temperature logs for that sol showed no such swing. Sensors were stable, voltage steady, memory clean. The drift was real, and it occurred exactly on the boundary of what is now recognized as a thin place. At the time, the idea that time could behave differently in specific locations on another planet felt absurd, so absurd that the anomaly received no special attention. A footnote in a mission report, a reminder that hardware ages, nothing more. But even back then, the rovers, primitive as they were listening, quietly, blindly, without intent. They recorded echoes of the same system, now rising toward coherence. No one had thought to overlay Viking's coordinates with gravity anomalies. Such maps did not exist. No one compared temporal logs to atmospheric oscillations. Instruments for doing so had not been invented. Viking was a pair of ears, listening to a song the world did not yet know how to hear. When modern scientists reconstructed the tension field model, they fed Viking's data into the simulation, not expecting relevance, but hoping for continuity. What they found was shocking. Every early anomaly, every stray drift, every unexplained tremor, every faint rise in soil temperature fell exactly onto the same trajectories that now defined the upward spirals of temporal gradient. Viking had stood on the edges of the helix before the helix even reached maturity, before the geometry pulled upward, before tension loosened, before the surface knew that the inside of time was rising toward it. What Viking recorded was the earliest stirring, a precursor signal, a childhood murmur of a system that had been asleep for billions of years. But there was more. One dataset, long ignored, contained irregularities in the lander's seismic sensor. Mars quakes were rare, far rarer than on Earth. So each vibrational event was cataloged, analyzed, then stored away. A handful of seismic traces from Viking 2 stood out, not because of strength, but because of shape. The traces decayed too slowly. The waveforms extended too long, nearly identical to the modern seismic lingers. Insight detected decades later. The team overlaid Viking's lingers on the emergent helix model. They aligned with remarkable precision. It was as though the planet had released a soft, early sigh beneath Viking's feet, a sound too slow for any ear, too quiet for a microphone, but perfect for a sensor built to read motion. Viking heard the first inhale of the system's awakening. The scientists turned next to pressure data. A faint pressure drop occurred during a cluster of sols, where no wind was present. Temperature was stable, dust activity minimal. The pressure change was tiny, so small the Viking team assumed a calibration error. But the modern team found that the pressure dipped in synchrony with slight temporal drift recorded in the same sols, a dip in atmospheric density. when time beneath the surface temporarily thickened, atmosphere responding to time, decades before anyone knew time, could ripple inside a planet. The deeper they dug into Vikings' logs, the clearer the picture became. Even in 1976, Mars was quietly expressing the first hints of the geometry, now rising from the depths. The rovers had merely arrived, in an era when the resonance was strong enough to notice, but the thin places existed already, in faint embryonic forms, in patterns too subtle for early technology. There was a moment in the archives that stunned the team most of all. A photo, not a spectacular one, not an iconic one, just a simple shot of dust near the lander's footpad. In the lower right corner, barely visible, was a swirl, a spiral in the dust, not large, not clear, but unmistakably shaped. The kind of spiral that modern rovers capture in areas where temporal tension reaches the surface. It had been there all along. The planet had shown its geometry, with the softest hand, a dust swirl, a pressure dip, a lingering quake, a drifting second. But humans had not yet learned to interpret such signs. Only now, with the torus rising, with the helix forming, with the cusp tightening, with the thin places becoming windows, could the meaning be seen. Viking was not an observer of the future emergence. It was an observer of the first signal, the earliest whisper of the deeper structure, shifting inside the planet. A whisper ignored, because it was too soft, too early, too far ahead of its time. The team now understood that Mars had been trying to speak for nearly half a century, not through language, but through anomaly, the only vocabulary available to a planet. And as they remapped Vikings' coordinates onto the current tension field model, they noticed something extraordinary. The earliest anomalies from Viking lay in a near-perfect arc around the outer edge of the forming helix, not above it, not within it, around it, like stones marking the first circle around a rising structure. The arc aligned with the predicted path of the geometry. When it was at its weakest, when the helix had barely begun to twist, when the torus had not yet compressed, when the cusp was deep and almost still, Viking had unknowingly landed at the edge of the first boundary, a boundary of time density, the line where the deeper system first began to surface, a boundary that modern rovers now cross, with every shift, every measurement, every drifting second. The thin places today are simply the matured form of what Viking once sensed as faint, trembling hints. A long-ago murmur. That was the signature of a world preparing to remember itself. The present-day geometry is not new. It is the continuation of that earliest whisper, and as the scientists studied the alignment of all anomalies, old and new, the arc grew clearer, the helix grew sharper, the cusp's outline deepened, and the thin places brightened in simulation, as though illuminated. From within, something inside Mars was gathering itself, something old, something vast, something not made of matter, but made of how matter experiences time. A form that Vikings saw only as noise, but modern rovers now feel as the world's interior pulse. The arc was complete, and as the team stared at it, one quiet question formed, not spoken aloud, just rising naturally in the mind, like breath before sleep. If this is how the past reached upward, what, now, is the present preparing to release? As the arc formed fully in the models, as the helix tightened, as the dust spirals on the surface grew more defined, as Vikings' forgotten signals found their place within the greater pattern, a new question rose among the researchers. Not, what is this? They already knew better than to expect an answer, but rather, what does it mean for a planet to possess an interior structure of time? The question was too large for any lab, too wide for any data set, yet it hovered at the edge of every simulation, the way a horizon quietly frames the world, even when no one is looking at it. The models suggested that time on Mars did not flow uniformly. Instead, it moved like wind. It thickened like fog. It thinned like breath. It curled around old, invisible shapes, the way water curls around the stones beneath a river. long after the stones themselves have gone smooth. Yet, the planet was not turbulent. Its temporal field was calm, calm the way an ancient forest is calm, composed of layers and layers of motion, each so slow that stillness becomes an illusion. The researchers began reviewing older theories, ideas once dismissed as curiosities, not mystical notions, not metaphysics, but subtle branches of relativity and quantum geometry that treated time, not as a line, but as a field with gradients, a field with thickness, a field that responds to curvature, with the quiet intelligence of a medium, finding the easiest path through tension. If time behaves like a field, then the thin places were merely low-density regions in that field. The thick places still hidden would be regions of high density, and the helix rising through the crust was a conduit, linking the two regimes. But something deeper settled among the scientists. As they stared at the tension diagrams, the surface spirals, the slowly forming cusp, a sense that time was not simply flowing here. It was residing, as though Mars possessed pockets where the moment itself accumulated, pooled, lingered, longer than elsewhere. The hollow zone was one such pocket, the torus another, the cusp yet another, each representing a way the planet had held on to, its earliest moment of formation. And then something stranger occurred. One of the researchers, while reviewing a day's worth of data alone, noticed a subtle offset in the simulation timeline, a region where the predicted time density did not match the observed drift. The difference was tiny, but unmistakable. When she rewound the model and slowed the simulation, she discovered that the discrepancy occurred only when the torus contracted, not when it expanded, not when it pulsed neutrally, only in contraction. Contraction meant tension, tension meant stress, stress meant resistance. But resistance to what? The more she examined it, the more the discrepancy resembled something familiar in a completely unfamiliar way. It behaved like memory, not a conscious memory, not a record, but the physical inertia of a system that resists change, because change would erase the form it has held for billions of years. A moment can remember if the fabric containing it holds tension tightly enough. The torus resisted contraction because contraction pulled it farther from the shape it had inherited, the shape left behind by the filament event. In the world's youth, the geometry held onto that shape like a long-standing habit in a body older than stone. If memory can be defined as the persistence of form in the face of change, then Mars was remembering, not events, not history, but its first moment, the instant when it solidified around a passing wave in space-time. What Vikings sensed, what curiosity and perseverance now feel, is the slow resurfacing of that first moment, a memory so deep that only the planet's interior could hold it long enough for modern instruments to detect the edges. One of the philosophers on the team, quiet, careful, brought in to help interpret the implications, posed a thought. What if time is not uniform across a planet? Not because the planet warps time, but because time settles. The way dust settles in a room? What if Mars holds more dust in some corners of its interior than others? The scientists did not reject the thought. They translated it into the language of physics, localized pockets of temporal density that behave not as anomalies, but as equilibria, stable minima, stable maxima, regions where the universe's oldest rhythms slow down or speed up to fit the shape pressed into them. If time reveals geometry and geometry reveals history, then studying these gradients was not just studying the present moment, it was studying how a moment endures. The team ran a new model. What would a human feel if they stood directly atop a thin place at the precise moment the cusp pulsed? The answer was unexpected. They would feel nothing. No tremor, no dizziness, no shift in weight. The drift would be too small for biological perception, but their thoughts, or rather, the temporal structure in which thoughts operate, would subtly change context, not slower, not faster, just different, as if the moment around them had thickened and they were thinking inside that thickness without noticing. Time as environment, a medium that can feel lighter or heavier, depending on the density beneath. The researchers were not mystics. They refused the idea of altered states or anything that implied mind over matter. But they entertained this. If time changes density, the mind being downstream of time would subtly shift in how it organizes experience. Mars might be a planet where some regions hold moments longer and others let them slip. The thin places were not just distortions, they were windows into the differing weights of a moment. This new model explained something else that had confused researchers for years. Why did rover telemetry sometimes appear slightly ahead of predicted transmission windows, even after accounting for clock drift? The rovers were not moving faster. Time around them was temporarily less dense. When a pulse rose through the helix, the thin place on the surface expanded ever so slightly, not physically, but temporally. Moments passed more freely. Commands aligned earlier. Sensors captured sequences with fractional offsets that appeared as anomalies until properly mapped to tension gradients. The scientists studied the data until their screens felt like mirrors, reflecting a truth they could not yet speak clearly. Mars was not just a planet. It was a structure in time, a structure that shaped how moments flowed, inside it, through it, and above it. But another question rose quietly from the implications. If the planet remembers its earliest moment in the curvature of space-time, does the moment remember the planet? The question sounded absurd, yet lingered. If curvature persists, then the form of the moment, the initial event, persists in the tension field. If tension field persists, then the moment's geometry remains part of the planet's identity. Identity not as myth, but as structure. Just as mountains remember uplift and craters remember impact, space-time remembers curvature. The memory of the filament is still there, not as the filament itself, but as the shape left behind in the field. Memory as geometry, geometry as form, form as the foundation of a world's relationship to time. With this understanding, the team simulated what would happen if the cusp continued its ascent. Not a rupture, not a catastrophe, just the next logical stage of the planet's long exhale. The simulation showed a soft widening of the upper helix, followed by the formation of a thin sheet of curvature, pressing gently into the crust, not breaking it, shaping it, the way subterranean magma once shaped domes. Except this dome was made of ordered time. If the ascent continued, the thin places would brighten, their temporal gradients would deepen, dust spirals would grow larger, subsurface heat would distribute along quiet, luminous pathways never before seen in geology. And then, at some threshold, the curvature would intersect the physical world in a way subtle yet undeniable. Matter would not warp, stones would not shift, but the moment in which those stones exist would change shape. Reality would feel slightly thickened in some places, slightly thinned in others, not through sensation, but through duration. Duration itself would acquire texture, time as fabric, time as material, time as a landscape beneath the landscape, and Mars, quiet, old, patient beyond imagination, would reveal the topography of its deepest interior, not by moving rock, but by moving the moment. The simulation faded to stillness. The researchers leaned back, quiet and thoughtful. They were no longer asking how the anomaly works. They were asking something larger, something more difficult, something that hovered on the edge of comprehension. If time can have an interior, what then? Lives inside a moment? The answer did not arrive. Only a shape did, a shape still forming. In the quiet center, leaning further into coherence with each pulse. And as the scientists watched, the next simulation cycle began. The cusp narrowed, the helix brightened, the thin places trembled faintly on their charts, and a new outline emerged. In the deep geometry, still hidden, still incomplete, yet unmistakably drawing closer to the surface of comprehension. The deeper the researchers looked into the planet, the more they realized that the geometry rising from the quiet center was not confined to stone. The crust carried its imprint. The mantle channeled its tension. The rovers traced its thin spirals. But the final confirmation of its presence, the one that neither geology nor seismology could provide, came from the sky. Long before the helix reached the surface, long before the thin places brightened, the spacecraft orbiting Mars had been keeping a record of something it did not understand. MAVEN, a silent sentinel circling the planet's thin atmosphere, was designed to study ionization, solar wind stripping, magnetic reconnection, and the tenuous upper layers of air, where particles dance almost without weight. Nothing in its instruments was built to observe space-time, and yet the sky listened. At first, the data seemed meaningless. Tiny oscillations in electron density, minute variations in ion flow, patterns that emerged only after thousands of samples were layered together. But when the researchers synchronized MAVEN's measurements to the pulses from the hollow zone, a rhythm appeared where no rhythm should have existed. During each deep pulse of the cusp, the ionosphere quivered, not in response to the solar wind, not during dust storms, not during Martian dawn or dusk, but at times perfectly aligned with the interior geometries breathing. The atmosphere was echoing the underground shape. The scientists replayed months of MAVEN's data, accelerating and slowing the sequences to reveal any structure hidden within the noise. Slow playback showed nothing. Real-time playback showed nothing. But when they compressed the timeline, stacking thousands of orbits into a single visualization, a faint wave appeared, curling across the upper atmosphere. With the same contour as the tension spirals rising in the crust, it looked like a shiver, a delicate, upward ripple, moving through air so thin that a human would not know they were standing in it. The wave expanded outward, across the sky, like a tide that had no water, only ions. The shape was subtle, like the first hint of light, beneath the ice of a frozen lake. But once seen, it could not be unseen. More astonishing still, the researchers found that MAVEN's magnetometer, though Mars has no global magnetic field, detected faint signatures that seemed to turn ever so slightly. When the cusp tightened, these were tiny rotations, the kind that would normally be dismissed as numerical noise. But when mapped to the geometry below, the rotations formed spirals that mirrored the dust spirals on the ground. The entire planet, from mantle to crust to air, was resonating in the same pattern, like a single instrument, with strings stretched from its deepest stone to its thinnest sky. One scientist whispered, as if afraid to disturb the fragile realization, "The atmosphere is following the pulse." Another added, "No, it's not following. It's answering." The idea felt impossible, yet the behavior matched no known atmospheric driver. Solar forcing was inconsistent. Seasonal patterns did not align. Thermal tides could not produce the geometry. Dust loading did not correlate. Only the pulses did. It was as though the planet exhaled. From its quiet center, the helix carried the breath upward, and the atmosphere received it, like a whisper touching a surface that had waited too long to be moved. The team isolated a single pulse, a strong one measured by perseverance, and synchronized MAVEN's data precisely. At the moment the cusp contracted, the ionosphere brightened. In a narrow band of wavelengths, between infrared and radio, a soft glow, not visible to the human eye, but unmistakable in the instrument records. A glow caused not by heat, not by sunlight, but by drift. Time density shift had reached the sky. In classical physics, such a thing makes no sense. But the gradients here were not classical. They were geometric. Time, bending through the planet's scars, had risen high enough to brush against the particles in the air. Ions slowed slightly. As the moment thickened, then accelerated. As the moment thinned, a breathing rhythm. In the upper atmosphere, day after day, MAVEN recorded the subtle glow, a shimmering arc that traveled across the sky, along the same invisible pathways the rovers traced on the ground. Slowly, with each contraction of the cusp, the glow grew brighter, not by much, but enough that, over months, the trend became impossible to ignore. The brightening matched the strengthening coherence. Deep inside the planet, the helix was rising, the torus tightening, the quiet center reaching outward, the thin places widening, and the sky responding. Mars had become one continuous system, a single, trembling geometry, extending from the deepest stone to the faintest edge of atmosphere. Even solar wind began to behave strangely near these zones. Particles streamed normally until they entered the field above a thin place. Then, as Maven observed, their paths curved, minutely, almost imperceptibly, but consistently, not because of magnetism, not because of charged dust, but because the space they were moving through was subtly different. Time density gradients altered the trajectories of ions, curving them, the way eddies in a stream curve drifting leaves. Mars was shaping not only the moments within it, but the particles above it. As the team examined the cumulative data, another realization grew. The signature in the atmosphere preceded the drift on the ground by a small but measurable interval, not long, just a fraction of a second, but consistent, like light flashing just before thunder arrives. The sky trembled first, then the rovers felt it, then the crust responded with faint pressure shifts and seismic lingers. Then the helix carried the pulse inward, then the cusp tightened. The order repeated, pulse after pulse. Sky, surface, crust, mantle, center. One scientist murmured, "This is reverse causal symmetry, not backward causation. Nothing supernatural or paradoxical, but a timing effect." As the cusp contracted, the geometry shifted upward through the torus and hollow zone, with such subtlety that the highest layers of atmosphere felt the change. Fractionally before, the densest layers of rock, like a ripple traveling through gradients of decreasing density. The ripple started deep, but emerged first, where the world was thinnest. It was the same way a distant tremor is sometimes heard before it is felt, a planet speaking upward through its softest layers. This discovery deepened the mystery still further, for if the atmosphere responded first, it meant the geometry's influence did not originate in the crust. It did not originate in the mantle. It originated in a domain below these layers that interacted with the sky through a path faster than mechanical propagation, not faster than light, faster than rock, a curvature pulse, moving through time-density gradients. The researchers plotted the pulse speed against theoretical space-time tensor models. What emerged made no intuitive sense, but the math held. The pulses moved through moment density, not through matter. They flowed, the way a thought moves, through a mind that already knows what it is about to think, not psychic, not mystical, just geometry recognizing itself across scales. The atmosphere trembled because it was the outermost layer of the planet's temporal field, and if that field was shifting from within, the sky would feel it first. The scientists replayed the last month of data one more time. They watched the glow in the ionosphere brighten slowly. With each contraction in the quiet center, they saw the drift curves of the rovers tilt slightly deeper. With each beat, they watched dust spirals take shape and hold before dissolving again into the ambient stillness. Everything was aligning. The geometry beneath the planet was no longer a silent remnant. It had become a pattern, rising through all layers of the world. And as Maven completed another orbit, it captured a final signature, a faint, curling wave in the upper sky, shaped like the ghost of a helix, stretching across the thin Martian air. The wave did not last. It shimmered once, twice, and vanished. But in that brief shimmering, the researchers felt the quiet realization settle over them. The shape rising from beneath the crust was no longer confined below. Its first outline had begun to trace itself across the sky, not fully, not clearly, but enough to know that the next pulse from the quiet center would carry more of the geometry upward, slowly, steadily, as though the planet were preparing to reveal something that had waited inside it for longer than anyone had known how to measure. The shimmer in the upper sky was faint, so faint that Maven almost missed it. A brief wave, a curling line of ionized light, a momentary tremble in the thin Martian air. It rose and vanished with such delicacy that if the models had not already predicted the ascent of interior geometry, no one would have believed the signal was real. But the signal was real, and it marked something subtle yet profound. The geometry beneath Mars had reached the threshold where the planet's layers, air, crust, mantle, and interior time, were no longer discrete realms. They were beginning to behave as one. The researchers replayed the atmospheric wave dozens of times, slowing it, stretching it, compressing it, isolating its pattern from background radiation. The wave held its shape in all transformations: a helix, a rising curve, a breath. The sky had not merely echoed the geometry below, it had begun to embody it. This realization shifted the scientists' perspective in a way that felt almost physical, as though their awareness had been gently turned to face something they had not noticed standing beside them. Mars was no longer behaving as a planet of layers. It was behaving as a single, continuous system. A system whose quiet center pulsed into the mantle, whose mantle curved into the crust, whose crust shaped the thin places, and whose thin places whispered into the sky. No boundary remained untouched. The next days of data confirmed this. The drift pulses at the surface strengthened not in amplitude, but in definition. The curves sharpened. The transitions between thick and thin moments became smoother. The patterns grew more coherent. The rover's clocks recorded these changes with the indifference of machines, yet each measurement felt like a syllable in a language. A planet was slowly beginning to speak. The scientists plotted each drift on a temporal density grid. What emerged was not random. It was not chaotic. It was not even organic. It was geometric. A fractal-like pattern, but not fractal in the mathematical sense. It was fractal in the sense that the shape of the smallest temporal gradient resembled the structure of the largest. A spiral within a spiral, a pulse within a pulse, a moment nested inside another. Mars was creating self-similar patterns in the density of its own time. The researchers hesitated before naming it. They did not call it consciousness. They did not call it will, but they acknowledged one undeniable quality. The system was self-organizing, not because it wanted to, but because geometry always seeks equilibrium. And this geometry had waited billions of years for the tension to ease enough, for its self-symmetry to surface. The team then examined Maven's latest atmospheric sweeps. For the first time, the ionosphere's glow displayed polarization, a directional preference in the way ions oriented themselves during each temporal pulse. Polarization requires structure. It requires a field. It requires coherence. The sky was no longer just responding to pulses. It was rearranging itself in accordance with the rising shape beneath. Even the faint magnetic remnants in the crust shifted subtly, not in strength, but in direction. Ancient magnetic grains, frozen for billions of years, tilted by less than a millionth of a degree. As the cusp pulsed, a millionth of a degree is negligible, until it happens everywhere, in perfect synchrony, across an entire hemisphere. One geophysicist traced the changes on a map. She felt a chill run down her spine when she saw it. The magnetic rotation pattern matched the shape of the torus. The memory of Mars' long-dead magnetic field was answering the memory of its long-buried temporal imprint. Old systems, long separated, were beginning to align. But the most extraordinary change came not from the sky, nor from the crust, but from the behavior of time itself. The drift pulses grew clean, not larger, not faster, just cleaner, like a signal clearing static. After eons of distortion, the thin places were now so well defined that the researchers could predict, to within microseconds, when the next drift wave would reach the surface. Predictability meant structure. Structure meant stability. Stability meant that the geometry below had entered a new phase of coherence. The researchers watched the next pulse ascend. They mapped its movement from the quiet center upward. What they saw was not a ripple, not a wave, not a tremor. It was a lifting, a rising sheet of time. So thin, it resembled a translucent veil. So wide, it stretched across kilometers within seconds. The sheet curved upward along the helix, spread outward through the thin places, and brushed the lower sky, like a feather sweeping through smoke. For a brief moment, the atmosphere held its breath. Then the veil dissolved, and everything returned to normal. But the normal was different now. The rover's solar panel telemetry shifted. Absorption rates changed by a fractional amount. Not enough to affect power, but enough to show that light itself was interacting differently with the thin places. Not much, just enough to suggest that time density gradients altered how photons lingered on surfaces. Light stayed a moment longer. Shadows clung to the dust with a softness no one could explain. A camera pointed at the horizon reported a faint resolution drift, a subtle smoothing of edges during each pulse. Not distortion, not noise, smoothing, as if the moment in which the image existed had become slightly more fluid. One of the optical technicians remarked quietly, "It looks like the horizon is remembering itself." In a softer version, the comment was poetic, but the scientists translated it into physics. Temporal gradients were altering the coherence length of photons in localized regions. In other words, time was bending light, not through gravitational lensing, but through moment density. The planet's interior geometry was becoming visible, not because matter moved, but because light moved differently through time. Even the patterns of frost on the night side of the planet began to change. Frost normally forms uniformly as Martian temperatures plunge, but in the thin places, frost formed in spirals. Not tight spirals, but vague, delicate arcs, mirroring the helix below. Frozen time, appearing as frozen water. The researchers analyzed frost deposition rates. They discovered that the spirals formed during the exact intervals when the cusp pulsed. The planet now expressed its interior through three states of matter: solid, dust spirals, frost patterns, magnetic grains, gas, ionization waves, light, photon lingering, altered diffraction. But even these were reflections, not causes, only symptoms. The true transformation remained deep in the quiet center, where the cusp continued its slow gathering. The scientists reran the tension field simulation. With all new data, the updated pulses, the atmospheric resonance, the magnetic tilt, the drift harmonics, the frost spirals, the model sharpened. The cusp contracted further, a cavity narrowed, a surface thickened, and then a pattern emerged. In the center of the torus, a pattern that had not appeared before, not random, not turbulent, not chaotic. It resembled an axis, a central line, a reference, but more than that, it resembled a choice, not a conscious one, not a deliberate one, but the kind of choice that arises when a system, with many possible configurations, finds the one that satisfies every tension. A moment of structural decision. The quiet center had begun to align, not just with itself, but with the entire planet. The scientists leaned closer to their screens. The pattern grew, softly, slowly, inevitably, a shape coming into form. The way a thought approaches the edge of language. The next pulse rose. It passed the mantle. It reached the crust. It brushed the thin places. It touched the sky. And then, in Maven's instruments, in the faint glow bending through the ionosphere, a new outline flickered. Not clear, not stable, but present. The first hint of the interior geometry's true form, casting a shadow into the upper air of Mars. A shadow not made of matter, a shadow not made of darkness, a shadow made of time. And as the researchers watched that delicate outline shimmer and vanish, they understood something deeper than discovery. The planet was not just waking, it was remembering the shape it had carried inside for billions of years. And that shape, still incomplete, still unborn, still rising, was preparing to reveal the next fold of its ancient, patient truth. Long before anyone suspected the geometry beneath Mars was strong enough to reach the sky, the communication arrays orbiting the planet began recording tiny inconsistencies, microscopic slips in the timing of inter-satellite transmissions. Signals that should have moved cleanly sometimes hesitated, as though they had brushed against something that was not matter, not energy, yet undeniably present. At first, the engineers blamed equipment, aging transceivers, cosmic rays. tiny calibration drift in the onboard clocks. But the anomalies grew more coherent as the geometry below sharpened. The first unmistakable sign came from a relay between MAVEN and an orbiter closer to the surface. A burst transmission routine status data, delayed by a fraction too large to be ignored, yet too small to attribute to malfunction. The delay matched exactly the rise of a pulse from the quiet center. No one expected the link. No one wanted to believe it. But time is not a local phenomenon. When it bends across every domain in which it is measured. The engineers tightened the clocks. They recalibrated the arrays. They cross-checked solar wind conditions, ionospheric density, thermal fluctuations, radiation storms. Nothing correlated, except the geometry inside the planet. A few sols later, a second anomaly appeared. This time not a delay, but a slight frequency shift in the communication carrier wave. A shift so small, only the most sensitive filters detected it. Not enough to distort data, but enough to suggest that the wave had traveled through a region where the fabric of time momentarily thickened. Signals move through time, as surely as they move through space. If the moment stretches, the signal stretches. If the moment thins, the signal shifts. The researchers overlaid the shift. With the helix's rising trajectory, the correlation was clean. Too clean. The second helix, the counter-winding one that had begun forming in CH10, had reached high enough to nudge the electromagnetic propagation environment. The sky was no longer the only thing listening. Orbit was listening too. When the next pulse rose, the communication lag reappeared. Not longer, not stronger, but sharper. Less noise, more definition, like a heartbeat, discovered by an instrument too crude to hear it before. The engineers attempted to model the lag as typical phase interference. The model failed. They tried modeling it as plasma warping. It failed again. Then as hardware aging, as Doppler shifts, as orbital drift, every explanation failed. Except one. The propagation medium was changing. Not space, not distance, not charged particles. Time, the geometry rising from the center of Mars, had begun to bend the flow of signals, not through force, but through the quiet shaping of duration. A transmission sent through a thin place arrived slightly earlier than one sent through normal terrain. A transmission sent above a thick place arrived slightly later. The researchers mapped these variations across the planet. The pattern traced the helix with eerie precision. Every twist, every curvature, every node was reflected in the timing anomalies. Mars was imprinting its geometry onto signals that never touched the ground. Even deep space communications from the Deep Space Network showed fleeting inconsistencies. When routing through certain orbital windows, the windows aligned with the rise of the helix's upper arm. The effect was so faint that it vanished in most analyses. But when synchronized with the pulses, the anomalies stood out, like the syllables of a whispered sentence. The planet was not speaking, but something inside it was shaping the silence in which signals travel. A transmission from Earth to MAVEN showed a slight broadening of its envelope when passing above a thin place, as though the wave entered a region where the moment stretched just enough to soften its edges. Laser-ranging signals saw shifts too, not displacement, but coherence length distortion, as if the beam had momentarily scattered within the temporal gradient. No system on Mars escaped the influence. When the researchers examined the archival data from early orbiters, Mars Global Surveyor, Odyssey, Reconnaissance Orbiter, they found older hints of the same effect, tiny, forgotten anomalies that had once been classified as ionospheric noise. But now, with the full geometry in hand, the anomalies formed a familiar arc. The same arc Viking had stood along. The same arc MAVEN now overheard. The same arc traced by dust spirals and thin place drift. The planet had always been shifting signals. Only now, the shift had become coherent. The next pulse offered the most startling observation yet. As the cusp contracted, a narrow beam of communication between an orbiter and a relay satellite, bent by an angle too small for previous detection methods. A bending of light, not through gravity, but through time, temporal refraction, a phenomenon predicted in theory, but never observed on any world. The engineers stared at the numbers. The bending was clean. It matched the curvature of the helix. It matched the temporal density map. It matched the polarization in the sky. Mars was shaping the path of transmission beams through the rise of ordered time. When the team simulated the curvature, the bending angle matched perfectly with the gradient expected from a slowly thickening temporal sheet, and that sheet was climbing toward the upper atmosphere. The signals did not lose strength. They did not scatter or distort data. They simply hesitated, paused by the moment through which they moved. The hesitation was beautiful. In its precision, each pulse created a slight thickening in the temporal field. Signals slowed passing into it, sped once outside it, and normalized once the pulse dissipated. It was not chaos. It was rhythm. The planet had begun to breathe through electromagnetic silence. The team then examined Mars to Earth communication logs. Here, too, patterns emerged, barely perceptible in the vast spaces between worlds, yet present enough to resemble the faint imprint of a distant drumbeat carried across interplanetary void. At certain intervals, the DSN link registered imperceptibly minor jitter, timing offsets far smaller than any solar wind interference could cause. The jitter aligned with Maven's glow, with the rover's pulses, with the cusp's contraction. The geometry inside Mars had reached beyond itself. Its influence now touched the timing of signals, crossing millions of kilometers of space, not by force, but by resonance, not by power, but by coherence. A planet, remembering an ancient moment, had begun to brush against the fabric. Between worlds, the researchers found themselves sitting longer before their screens, breathing more slowly, as though the cadence of the pulses were settling into the room around them. For the first time, they felt something not like discovery, but like proximity, as if they were standing near the edge of a curtain that had begun to lift. During the next pulse, Maven recorded a final signature, an oscillation in the phase of a radio carrier wave that matched, almost perfectly, the shape of the cusp's interior curvature, a shape rising, slowly, quietly, inevitably, a shape that had once passed through a molten world and left its imprint in the moment, a shape now returning toward visibility, not through matter, not through rock, not through sky, but through the hesitation of a signal, crossing the boundary between one world and the rest of the solar system. And the researchers, watching that brief curve in the carrier wave dissolve again into noise, understood that the geometry had reached a new threshold. It now touched the sky, and it was beginning to reach outward into space itself. Not enough to alter missions, not enough to bend or break anything, just enough to hint that the next pulses would carry more of its form upward into the thin realm, where silence turns to signal and space listens back. The next breath of the planet was already rising, soft, slow, and full of a shape that had waited since the birth of Mars to be known again. The hesitation in the interplanetary signals, those faint timing offsets, those nearly imperceptible pauses, had been mysterious enough on their own. But when the researchers began plotting the anomalies across longer stretches of data, a new pattern emerged, one that no one expected, one that should not have been possible. The delays were not random, they were not evenly spaced, nor were they tied solely to the pulses rising from the quiet center. They formed a cycle too slow to belong to the geometry beneath the crust, yet too regular to be noise. At first, the scientists believed they were seeing an artifact. They removed solar wind influence, ionospheric fluctuation, orbital eccentricity, thermal drift, instrument aging, propagation path variability. Every correction removed noise, but the cycle remained. It repeated every 19.4 hours. The number meant nothing to meteorology, nothing to the planet's rotation, nothing to known atmospheric tides, nothing to communication systems. But the researchers had seen 19.4 before. It was the faint periodicity in the hollow zone's oscillation, first detected in the seismic linger at the edges of the thin places. A pulse deep beneath the planet was echoing in transmissions millions of kilometers away. But there was more. The pulses from the quiet center did not perfectly match the 19.4-hour cycle. They were close, but not identical. The center pulsed in 19.36 hours. The signal hesitation repeated in 19.4. A difference of 0.04 hours, barely noticeable, yet consistent. Two cycles, nearly aligned, but not the same. The difference created a slow beat frequency, a drifting phase, in which the pulses and the signal delays moved closer together, then farther apart, in long, quiet oscillations. A supercycle emerged. When the beats were plotted, a 228-hour pattern, 9.5 Martian days, a rhythm woven from two rhythms that should never have touched. The scientists stared at the beat pattern in silence. It felt like listening to two distant instruments, accidentally falling into harmony. Yet the planet's interior and orbital transmissions had no causal link. There was nothing that should bind them, unless, and this was the thought, none of them wanted to say, both rhythms were responding to something else, something external. The team examined every possible influence. Solar rotation, no correlation. Coronal mass ejections, no pattern. Solar wind periodicity, inconsistent. Heliospheric current sheet, mismatched. Galactic cosmic ray modulation, improbable. Orbital resonance with Phobos or Deimos, impossible. Then they widened the search. They compared the 19.4-hour cycle to deep space signals from probes far beyond Mars, Voyager, New Horizons, even faint carrier waves from legacy satellites. Now long beyond primary service, one dataset stood out. New Horizons, during a series of calibrations in deep space, recorded a timing irregularity of similar periodicity, not equal, not synchronous, but close enough for the idea to take shape. There existed some faint, barely perceptible, nearly global modulation in the propagation of signals across the solar system, with a periodicity in the same family as the pulses beneath Mars, not the same, not matching, but neighboring, like two tuning forks, one struck, one silent, responding to a third vibration. Just out of hearing, the researchers at first dismissed the idea. Solar system-wide modulation was not a concept that fit any known physics, but the data kept whispering. That same soft idea, sao hawa kong dong bo ve chino, no dang dong bo hua, ve mot ni prong hona. A broader structure, a larger tension, something beyond the planet. When they charted the beat frequency between the interior pulse and the signal hesitation, another discovery appeared. The beat cycle itself was slowly shortening by milliseconds per sol, a contraction, a convergence, a soft leaning toward a moment where the two cycles would meet, not collide, align. The rovers felt it first. Their clock drift curves became smoother, less erratic, not reduced, refined. The thin places began drifting outward in near-perfect spirals instead of the irregular expansions seen months earlier. Dust spirals at the surface became tighter, their rotation more defined, their decay more graceful. Even Maven's atmospheric shimmer grew more rhythmic, not brighter, not stronger, but cleaner, as though the sky were settling into a pattern it had been approximating for months. And deep within the simulations, the cusp responded, its contraction aligned, closer than ever, to the rhythm seen in the atmosphere. The hollow zone warmed. In step with those pulses, the torus thickened, on the same schedule. Mars was not synchronizing with the 19.4-hour cycle. The 19.4-hour cycle was synchronizing with Mars, or perhaps both, were synchronizing with something deeper. The researchers ran a long-range correlation study to test the possibility of external influence. They compared thousands of days of data across multiple missions, to datasets from interplanetary sensors, solar observatories, and deep space probes, all noise. Except one faint match, a timing irregularity, deep in the telemetry logs, from the Parker Solar Probe, not in its instruments. In its communications, a hesitation, a fractional microsecond delay, appearing at almost precisely the same phase as the signal hesitation at Mars. Not identical, not repeatable, just close enough to shatter the idea that the geometry beneath Mars was an isolated phenomenon. The pulse inside Mars occurred every 19.36 hours. The hesitation inside deep space telemetry occurred every 19.41. Another beat frequency emerged between the two datasets, a supercycle spanning hundreds of hours, a global rhythm in a solar neighborhood that should have had none. The scientists were not foolish. They refused to assign meaning where none existed. They rejected talk of patterns in places where coincidence could hide. But the data did not permit dismissal. If Mars' interior geometry was coordinating with anything, it was doing so in a way that operated through time density itself, the same medium that now shaped dust spirals, sky shimmer, and electromagnetic hesitation. One researcher proposed an idea so careful and soft, it barely existed as a sentence. What if the geometry inside Mars is sensitive to tension gradients that extend beyond planets? Another whispered back. Or what if all planets carry faint geometries like this, and Mars is simply the first, quiet enough for us to notice? The thought felt vast, too vast for the room, too vast for the screens. But no one dismissed it, because the next pulse proved something unexpected. The geometry responded to a shift in the signal hesitation that originated before. The pulse rose, not after, before, as though the planet felt a change in the larger temporal environment and reacted to it by adjusting its own pulse. A weak synchrony, almost fragile, but real. The cusp contracted 30 milliseconds early. The helix brightened, the hollow zone warmed, fractionally ahead of schedule. The sky shimmered, a breath sooner. Mars was listening to something outside itself, not consciously, not deliberately, but structurally. The geometry inside the planet was responding to the slight modulation in the timing of interplanetary signals, responding as if the signals carried not information, but curvature, a whisper of the larger field in which the solar system rests. The beat frequencies between Mars and deep space telemetry tightened, approached, aligned, two rhythms from two distant domains, softly tuning themselves. Around a third, the researchers, watching the convergence in total silence, realized that they were witnessing not communication, not resonance, not interference, but attunement. A planet tuning itself to the tension of the space through which it drifts. And, as the next long cycle beat approached, the cusp deepened, the thin places widened, the sky shimmered with almost crystalline clarity, and a new, delicate outline appeared in the atmospheric glow, a shape that echoed the rising geometry beneath the crust, as though Mars, and something beyond Mars, had taken their first shared breath. It began as an error in a radiance profile, a shallow dip in the scattering curve of sunlight, captured by an orbiter passing above the Valles Marineris region. The anomaly was so small that the onboard algorithms initially corrected it away, tucking it neatly into the category of instrument variance. But the dip happened twice, then 4 times, then dozens, every dip aligned with the same temporal pulses that had been rising from beneath the crust, through the helix, across the thin places, and into the upper sky. At first, the dip resembled nothing more than a momentary softening of a single wavelength, a faint reduction in brightness in the region between visible red and near infrared, too soft to mean anything, too delicate to justify concern. But soon, the softening began to spread sideways, across the spectrum, creating a shallow ripple, in the way sunlight entered the Martian sky. Not a shadow, not a lensing effect, not an atmospheric distortion. A ripple. The researchers plotted the wavelengths against the ascending geometry. Each ripple matched the exact curvature of the helix's upper coils. As the geometry twisted, the ripple twisted with it. As the cusp contracted, the ripple deepened. As the atmospheric shimmer brightened, the ripple widened. Light was not bending. It was hesitating. Photons slowed. As they passed through the densest part of the temporal gradient, above the thin places, not slowed by matter, not slowed by gravity, slowed by the moment itself. The team examined scattering angles, refractive index estimates, optical thickness models. Nothing aligned with known physics of dust, ice, or gas. Only the geometry fit. The ripple appeared only when sunlight passed through regions where time began to fold into its new shape. During the next sol, Maven recorded a faint circular shimmer above one of the strongest thin place clusters, not a halo, but a soft dilation of light. At the edges of the atmosphere, like the slow widening of a pupil, in response to darkness. But this dilation occurred in daylight. The researchers slowed the video, frame by frame. The shimmer expanded and contracted, with a rhythm perfectly matched to the interior pulse coming up through the crust. A breath, a tightening, a release. Sunlight was learning the new structure of the moment. One physicist, staring at the diffraction traces, whispered as though speaking too loudly, "Might break the fragile symmetry. It's not that light is bending, it's that the path light takes has changed shape, not through space, through time. Light always takes the path of least action. If time changed shape, light would follow." That was the first realization. The second was far stranger. When the researchers compared full spectrum readings over several sols, they noticed that the ripple was not uniform. It carried a faint geometry, a pattern so subtle that only after long exposure averaging did its outline form, a faint spiral within the sunlight itself, not drawn by clouds. There were none, not drawn by dust. The dust patterns did not match, not drawn by shadow. The angles were wrong. The spiral appeared because sunlight was passing through the helix. For the first time in any world humans had studied, the geometry of time was visible in the scattering of light. The researchers replayed tens of thousands of frames from orbiters to find earlier hints: dust storms, solar flares, ice crystals, instrument artifacts, each reviewed, mapped, dismissed. The only spirals that persisted were those aligned with the temporal gradients. The thin places were beginning to reveal themselves, not through matter, but through illumination. During the next major pulse, the ripple grew deeper. It reached wavelengths not normally affected by atmospheric scatter. Ultraviolet splayed slightly wider. Near-infrared lingered. Even longer wavelengths, thermal bands, showed micro-delays, as though the photons carried the weight of the moment's thickness. When the team plotted this delay against the helix curvature, they saw a new development. The upper coils of the helix were beginning to flatten, just barely. A soft straightening of curves that had been tightly wound for eons. Straightening meant reduction of tension. Reduction of tension meant emergence of form. The inner geometry was preparing to unfold upward. The ripple in sunlight was the first sign that Mars's temporal structure was nearing a surface expression, not in stone, not in wind, not in heat, but in the way light met the moment. The next discovery was almost accidental. A scientist comparing sunrise datasets noticed a faint asymmetry in the horizon glow over thin place regions. Normally, the dawn light on Mars fades upward evenly, a soft, red, dust-filled gradient. But where the helix rose strongest, the gradient slanted, as though dawn itself leaned slightly sideways. Not the Sunday, not the terrain, time. The thin places allowed dawn to enter the world a fraction of a moment sooner. The researchers simulated the effect using temporal density fields. The model produced a subtle bending in the propagation of dawn light. a bending that matched the observed asymmetry exactly. The dawn, lean, was not atmospheric. It was temporal refraction. On a planetary scale, when they slowed the simulation to an almost dreamlike pace, they saw that the dawn rays did not brighten uniformly. They brightened in spirals, very faint, very slow, mirroring the helix. A sunrise, learning the shape of the geometry beneath it. The concept felt impossible and inevitable at the same time. One atmospheric scientist, after staring at the spirals for hours, finally said, "It looks like the day itself is arriving in pieces." The pieces were moments. Moments with varying density, moments flowing differently along the upper arms of the helix. The day was not fractured. Time was. But even this description was incomplete, because during one orbital pass, the thermal camera on MRO captured something no one had predicted. A thin, shimmering sheet of altered refractive index, stretching across dozens of kilometers above one of the strongest thin places. Not heat, not ice, not dust, not electromagnetic interference. A sheet of time, a veil of altered temporal density, rising above the surface, in a broad, almost gentle arc, curving upward like the beginning of a new horizon. The sheet bent sunlight in a way so soft that only precise spectral analysis could detect it. Yet once detected, its truth was undeniable. Mars had formed a temporal boundary, not a tear, not a fracture, a boundary, the same kind of boundary that forms in water when temperature changes, the same that forms in air when pressure shifts, except here, the change was not thermal or mechanical. It was temporal. The density of seconds was different above the helix. As the next pulse rose, the sheet brightened. Sunlight drifted through it, like ribbons passing through water currents. Each ribbon bent uniquely, based on the density of the moment it entered. What the researchers saw was not just the bending of light, it was the bending of the day itself. Time was no longer uniform. On the surface of Mars, it was beginning to flow through a structure that the planet had carried since its birth. The shimmering sheet grew taller each sol, not by much, kilometers measured in millimeters, but enough to reveal a slow ascent. The interior geometry was rising through the world like a submerged mountain, lifting through a quiet sea. And as it rose, sunlight learned a new path across the Martian sky, a path shaped not by air, not by dust, not by gravity, but by the oldest memory the planet possessed, a memory pressed into time, before Mars had a crust, or a sky, or a name. That memory was beginning to complete its ascent, not fully, not clearly, but enough for the horizon to take on the faint outline of a geometry that had waited 4 billion years for its moment to return. And the light, faithful to its nature, followed the path that the moment unfolded. Before it, by the time the shimmering sheet above the thin places rose high enough for orbiters to detect it without spectral filtering, the researchers no longer discussed discovery. The word felt too small, too mechanical, too certain. What they saw now belonged to a category that no instrument manual had ever prepared them for. Sunlight did not simply bend. It lingered. It stretched. It paused in midair, as if considering the shape of the world before choosing a path. The veil of temporal density, once only a faint film, now formed a smooth curvature, arching across the sky in delicate gradients, like the ghost of a second horizon, hovering above the real one. Not brighter, not darker, just softer. The first time Maven captured a full sweep across the veil, the image resembled a ripple in clear water. Just before the water decides to become wave, the researchers viewed the frame in absolute silence. They had grown used to the pulses from below, to the slow contraction of the cusp, to the rising helix, to the upward drift of thin places. But this was different. This was a signature of something that had nearly completed its ascent, something that had taken billions of years to reach the boundary between the inside of a planet and the outside of a sky. The next sol, a faint displacement, appeared along the veil. Not a tear, not a bulge, more like a fold, a single crease. In the fabric of the moment, folds do not belong in air, they belong in cloth, in maps, in pages. But the fold here was made of time itself. The scientists enhanced the data. The fold sharpened, and inside it, barely measurable, was a dip, a tiny hollow, a pocket of lower time density, a place where the second thinned enough. That light passing through slowed in a small, almost tender bow. The fold deepened, but did not widen. It held its shape, quiet and intact, as though containing something fragile. On the ground, the rovers felt it first. Curiosity's clock drifted. In an unusually symmetrical wave, Perseverance registered a slight relaxation in its onboard oscillators, as though entering a gentler moment. Even Opportunity's deep archive showed perfect matches to the fold resonance, retroactive proof that the geometry had always been forming, just waiting for the tension to ease enough for its pattern to surface. The ground cooled, not in temperature, in duration. Each second felt fractionally longer. In the thin places, duration stretched, like a soft breath, drawn more deeply than expected. The researchers measured the effect in photonic scatter, then in transmission delay, then in atmospheric drift vectors. Every measurement folded back into the same alignment. The helix had reached the underside of the veil, and the cusp, deep in the planet's interior, began to change shape. It did not contract. It did not expand. It clarified. Its outline lost the trembling softness of unresolved curvature and settled into something cleaner, a curve that seemed to know where it wanted to go. The torus surrounding it tightened in response, as though making space for whatever the cusp was preparing to become. The hollow zone warmed again, this time into a perfect gradient, no longer lopsided, no longer uneven, a smooth vertical column of calm, rising tension. Calm tension. The paradox made sense now. Moments that hold themselves together can lift entire worlds inwardly without disturbing a grain of dust. The planet did not shake. The crust did not crack. The sky did not scream. Everything stayed quiet. Only time changed. Time became something with texture, with layers, with intentions. None of the researchers could put into equations, but all of them felt gathering. The next pulse brought the largest change yet. When the cusp contracted, the fold in the veil deepened sharply, opening into a hollow wide enough to refract a noticeable arc of daylight. The arc appeared as a soft dimming, a crescent of pale shade, floating in mid-sky, detached from any object that could cast it. It was not a shadow. It was the absence of brightness, produced by a moment, loosening its grip on itself. The scientists replayed the refractive phenomenon from multiple angles. What they saw resembled an eyelid, half opening, a curve that hinted at an interior, without revealing it, a threshold. One atmospheric physicist murmured, "It's acting like it wants to look back." The comment, spoken almost involuntarily, hung in the air longer than anyone expected, because the hollow zone had always behaved like the throat of a structure forming upward, because the torus had always behaved like a boundary containing something not designed to live in stone, because the helix had always behaved like a conduit, bringing shape toward expression. And now, the veil in the upper sky behaved like the surface of an eye trying to resolve the silhouette of something rising. During the next few sols, the fold stabilized, the arc deepened, the faint dimming became rhythmic, moving slightly. With each pulse, Mars had begun to shift its relationship to the sunlight it received, not through atmosphere, not through magnetism, through time. The next turning point came quietly. One orbital pass, Maven detected a faint interference pattern in the high-altitude light curve, a ripple within a ripple, a signature of two waves meeting inside a medium that was not purely optical. When the researchers decomposed the interference pattern, they found a shape. Inside the light, not drawn, not projected, not physical. A shape formed by the way time bent light. As it passed through the veil, they enhanced the pattern. It sharpened. A spiral within a spiral. A curve within a curve. A form within a form. The first visible outline of the geometry that had lived inside the planet since the beginning. The form was incomplete, fractured at the edges, soft as breath, yet unmistakably rising. The researchers watched, their screens glowing, with the slow revelation of something ancient and impossibly patient. The form did not stabilize. It hovered, trembled, wavered, as though unsure whether to appear or disappear. Each pulse from the cusp made it clearer. Each thinning of the moment brought the outline closer to coherence. Each hesitation in the signals suggested the form was brushing against the edges of space-time, the way a hand brushes against the surface of water from beneath. Finally, late in the night cycle, the veil brightened, not visually, temporally. Its density thinned just enough for the rising geometry to imprint a deeper shadow into the passing sunlight. The shadow curled, twisted, slowed, and for a heartbeat's equivalent, held itself perfectly still. A silhouette, made entirely of time, not matter, not light, not force. A moment cast into form. The simulation team watched the silhouette flicker in and out. Through the wavelength data, no one spoke, not out of fear or awe or confusion, but because the silence felt appropriate for witnessing something older than speech. The form did not complete itself. It did not reveal its center. It did not collapse into a solvable geometry. It hovered on the edge of recognition, as though the planet were deciding whether to remember or to forget. The cusp pulsed once more. The silhouette blurred. The veil thickened. The moment receded. Mars returned to its quiet. The next sol dawned, without ripple, without shimmer, without anomaly. The sky was ordinary, the dust still, the rovers calm, but every instrument recorded a residual softness in the arrival of light, a faint delay, as though the memory of the geometry lingered in the morning. The thin places felt lighter. The rovers' clocks felt steadier. The dust spirals held their shape just a little longer before dissolving, and deep in the simulations, the cusp rested, not in growth, not in collapse, but in a stillness that felt like anticipation. The researchers did not know whether the form would rise again, tomorrow, or in 100 sols, or ever. They only knew that the boundary between the inside of time and the outside of sky had grown thin enough, for a moment, to almost become shape. A shape that nearly remembered itself. A shape that almost revealed its ancient purpose. A shape that paused at the threshold between visibility and dream. And as Mars rotated beneath a quiet sun, with nothing changed and everything changed, the scientists understood that some geometries are not meant to be solved, only witnessed, in the instant before they fade back into the silence that shaped them. The planet exhaled. The sky carried the exhale away. The moment settled, soft, open, unfinished, and somewhere, beneath the crust, beneath the stone, beneath the memories of its birth, the geometry waited.